That's the size of their mouth. The balls. And there's not the same to the.
So hard to explain, like, and then just make it away to how much the sun it's not obvious. Nature just gets to be like that.
I do better than the one better.
Then something else kicks in, and it's
Yeah.
so that your basically kicks in the middle of the motor. But you're supposed to have your item of your water supposed to have two ways, right? So you get the isotopes multiple water, which comes to the stimulant. And the ideal one goes to the boiler, and if you want hot water, the boiler. What if you want central heating and not water stuff? So that's why there's this output from this specific motor. When it gets to the far side, it's that other microcylinders, and you check it. You're in the middle. You don't just want DC, you fuck up the motor. So there's another bloody resistor in this orange wire, which is the output, which actually is connected to weight when you get water, just to give you a little bit of these, the basic camera as well. I have another stuff in the YouTube video, which is actually amazing. But I kind of looked, I thought, how does this work? Why is it work? What the fuck are you supposed to be doing? And I looked at the circuit diagram and went, no, I'm still playing the lighter. This is how our beginning system works. So I put it in manual override, it goes to the middle system up everywhere. Why? Now I know why. I will think, I've got to reflect it. But the floor is very concrete, so we're going to get in there. Yes.
Okay. Are you running this?
Yes.
Are you running this whole section?
Me and Salon, two presenters.
Okay, the whole.
No, just this.
Are you running the whole?
I'm the organizer.
Okay. So we got two of these,
Yes.
and just for the camera and people online, if whoever is talking,
Just
have them stand
stand
up.
up. Yeah, I know.
Yeah.
I'll make them aware. Don't worry.
I'll put them. Put them right here.
Yeah, sure. So this is the laptop. You just, I'll do some welcome day with this slide.
Okay.
And then you just click on this and choose your
Perfect.
choose your thing and what's all set up.
Okay, perfect. And then go next. And
Yeah. So we just switch it here.
okay, perfect. Awesome. Thank you very much.
Still have time.
You can switch to. Left and right. Left and right. So you're not presenting from here, you're presenting from the cloud. You just control the button.
At least I can see what's
Sorry about that.
I'm just here as a visitor. I'm not shepherding or anything. I have.
Introduction for the
Thank you. Hello. Does it work? Can you hear me? Okay, perfect. So good. Thank you. Good morning and welcome to the live patching micro conference today. I have just one question to ask. If you want to take part in discussions, which is really welcome, please use the mics. We have those sketchbox thingies, and please also stand up while talking so that you are clearly visible on the camera. And we have 6 speakers today with interesting topics, and we'll start just now. So, Breno, you're free to.
Thank you very much. Good morning, everyone. I'm Breno. I work at Meta. I've been working with Live Patch with Thong and Young-Hon Son, who is going to talk after me. And we decided to submit this presentation to expose some of the problems we have today and try to figure out like a solution at upstream so we don't need to have custom patches. So at Meta today, we have some custom patches to do what we need to do, and that's what I'm going to expose. And they're custom, and how do we figure out together as a community how to upstream those patches. I've been talking to some other folks, kind of almost all of them have the same problem. So I think it's a good time to use this conference to discuss like what can we do as a community to fix some of those problems. Anyway, I'm going to give an introduction on how do we use Live Patch, how we are monitoring it, and some of the challenges. And feel free to stop us at any time to discuss if you think doesn't make sense or if you have some ideas on how we can do it better. Yeah, just raise your hand. Yeah, so what we know is that at Meta, installing a kernel is super slow. So if you have one machine, it's going to take maybe a few minutes to install a new kernel. At Meta, at the scale we have, it's super hard. So we have what we call boxcars, and we split the data centers into maybe 50, what we call MSB. And almost every day, there is a train that goes there, undrains the machines, install a new kernel, does firmware upgrade, drain the machine, install the kernel, firmware upgrade, whatever, and undrain the machine, and the machine is serving traffic again. So if you need to install a new kernel after that, you need to wait for the train to go to all the MSBs and come back to that. So it takes like sometimes 45 days to install kernel. So that's kind of the problem that motivated KLP to be used. And yeah, so that's why we are using KLP in the first thing. The second problem is when we are rolling out a new kernel, so let's suppose we start rolling out 6.6. And we start rolling out to some tiers, like we have a few tiers like RC, meaning that if we break, if we have some memory corruption, that's kind of okay. And then we go to other tiers up to the most important tiers. And sometimes if we have a problem, we need to restart with a new kernel, with the new fix, and that slows things down. So we also use KLP to speed up that one. So we don't need to stop and restart. We basically fix that and continue the rollout. So that's the case too that we use it. Any questions so far? Oh, perfect. So that's the motivation for KLP. The way we run KLP, or the way we roll out KLP, is we have several phases. Basically, we have an RPM, and we have several phases. So we split the whole servers into 23 phases right now. We deploy to the first one. And remember, this is for KLP, not for kernel. We install in the first shard, we have a bake time, what we call for 4 hours. And then we are measuring those machines and compare those machines with the one without the KLP, and making sure that this is as good as the previous version. If it is as good as the previous version, we go to the next step. 4 days later, we were able to roll out the KLP fleet-wide. Of course, that we can speed up if we are having problems, but the trade-off is we are not getting a lot of metrics, so we have a little bit higher risk. And we do cumulative KLP, so we just have basically one KLP applied. If we need a second one, we are going to append the fix for the first one plus the fix for the second one and roll out that one. So basically, if you SSH into any machine in the fleet, basically one and only one KLP is applied. Yeah, so that's the rollout mechanism. This is a screenshot of our tool. How long does it take? 23 phases. And that's what we control. So if there is any metric, and that's where I want to start changing the presentation to. Yep. Just get the box.
So when you say a phase, is that just a subset of the nodes that you're trying to patch?
Exactly. We call that shard. And there are a set of machines that is on that shard. So the RPM is just installed on that shard. We bake time, we compare that with the previous version, and if everything is good, we
So
mark it as green.
The process you described earlier of actual deployment of the kernel itself, not the live patch, you said it took 45 days.
Mm-hmm.
And the train, or the single train that went through your fleet.
Right.
Why don't you shard that as well and have parallel trains leaving for subset of nodes that you want to update?
That's a good question because we use different systems for different rollouts. For kernel, we use a different system that we can talk more later, but we basically go in a different way. We start per region instead of like fleet-wide. Why don't we do that for KLP? Because sometimes that region does not have the kernel we are fixing. For instance, let's suppose we have region 1 that contains a new kernel 6.6, and we are KLP kernel 6.5. We cannot use that. We need to find hosts in the fleet that has 6.5.
So as you start rolling out the KLP, let's say you discovered another bug.
Okay.
Right? And you have a new live patch that you would accumulate into the current patch that's rolling.
Mm-hmm.
Do you reset the rollout and start with the first node, or you just leave the first node running that potentially buggy kernel and just proceed further with the new kernel?
That's a good question. For KLP, we can roll back. It's easy to roll back, yeah. And restart. Cool. Okay, so that's the monitoring part, and that's where I'm starting to move the discussion towards, because I think that's where we have some of the problems. Again, so the rollout mechanism is we have a rollout manager, we have a packager rollout, basically an RPM that goes to a shard, install an RPM, and the service health check that gives the information to the rollout manager, basically say, yeah, we are good so far, move to the next one, or stop the rollout because something is weird, we need a human to fix this problem. And this is what we see. We have two kernels here, the blue one and green one. So we need to know if the blue one is better than the green one to make a decision. In this case,
It's like, what color is that dress?
Anyway, but my point here is we use this kind of metrics for a lot of things. The first one is the kernel crashing. That's easy, right? But we also want to know, is this kernel giving some warnings or bugs, or is the performance bad for this kernel? And remember that we have metrics for a bunch of things. Is the web server performance as good in the KLP version compared to the standard version? So we have a bunch of those, and we have a code that it needs to check all of them. If everything is green, proceed, otherwise stop.
So are all the nodes here running the same workload, or there's a diversity of workload that the nodes are running?
Diversity of workloads, but we get information for those workloads that are running that kernel. So for instance, let's suppose we have the same kernel database and web. So the metrics we have for web is just for the web servers. This is kind of consolidated in one table that we can query. So yeah, for instance, another problem we have is applications are crashing. So we have core dump, an application crash. We report it to the database, say application X, like engine X crashed. And we want to know, does it crash or did it crash on KLP version or not? And sometimes, as you know, like things crash all the time. Like we want to know how many crashes do we have on this kernel compared to the other one, and we want to normalize that and compare. So and that's where the challenges start to be. So now we need to start reporting what is the KOP version for that crash. Or for the web server, what is the performance for this web server? And we need to start reporting what is the KOP applied for this kernel that is running on this web server. And that's where I'm starting to move towards. We have this information from different places. And usually these different places mean different teams. And some of them are not even aware of KOP. They just care about like kernel. What is my kernel? And what are the disk latency for this kernel? What are the user space for this kernel? So that's one of the challenges we have, that it's not easy to get the KOP version. So people can easily report that this is the kernel, this is the KOP. Yeah, so, and we have, as I said, we have random teams producing this metric because the kernel team just want to consume whatever people think is important. And remember that we are talking about web server, database, ads, like a bunch of things. And all of them now we need to have the KOP version that is applied. And challenges. So basically we have 3 of them. I'll just cover the first one, and then I will transition to Song, who will cover the second and third one. So the first one is the one that I told you. How do we get the KOP that is applied on that machine in different forms so I can report back to the data warehouse so we can consume later? And it's not easy to get this KOP right now, mainly because we are consuming these from different places. And it's even harder to find if a KOP is applied. And you say, it's easy, you just go to sys live patch enabled. Well, but sometimes the kernel crashed. So we need to investigate the crash dump to find if the patch is applied. And that's the challenge we have. So challenge number 1. So let's just start from the beginning. We have NAT console at Meta today. So every kernel message is pushed to NAT console. And we don't have KOP. So if you apply a patch, a KOP patch into the kernel, NAT console will report the same kernel version. What do we need to do? This is ugly, but that's what we have in production. So we create a dictionary at print K that creates the uname key and appends the uname with the hotfix. And at every KLP, we define a macro called HV hotfix version. That is hotfix 1. And in the print K, we append that to the print K dictionary that is going to populate NAT console. So at every KLP that we apply to a kernel, we change a macro that will change what is populated to NAT console.
So this is a similar thing, not using print dictionary. So each live patch is uname. So we override really, so like do it in a live patching way. The problem with uname is that there's really not much space.
I have a slide for that.
Okay, so
That's the ideal scenario, but I don't think it's feasible. But let's discuss that because that's an interesting thing. Anyway, NAT console is the first problem. Second problem, crash dump. So an application, a user space application crashed. I'm sorry, kernel crashed in this case. The kernel crashed. We have a VM core for the kernel, and we need to investigate if the KLP is applied or not. And this is our code for production. So we need to figure out if the module is loaded or not. But remember, you can have the module loaded, but it's disabled. So there is no way for us to be sure that that KOP was really enabled. So we assume that if the module is loaded, the KOP was applied, just because we don't have more information. So that's another way that I think we definitely want to improve. And in the third case, we need to read sys kernel live patch, and we have a function today to read that and parses the enable, disable, whatever. But then we need to have like the same function or the same helper and different languages for all the workloads to consume that. Some of them are in Rust, some of them are in C++, some of them are in Python. So kind of we need to replicate that because the way the kernel exposes that needs some parsing. That is not ideal. So yeah, so that's the third problem, the least important one, but eventually we can improve that. That would help us to have a cleaner system. Anyway, so next step, is this really a problem for other companies? And how do we fix that instead of playing whack-a-mole with the KLP today? I have some suggestions here, and the first one is exactly what SUSE is doing, change UTS name to append. I'm not sure if it is feasible to do upstream. So do you want to share what you do at SUSE, please?
So, as I said, so we also like UTS name. So we write release string. So originally we appended /lp string and with a bit hash, so which points to our bit record with the live hash, so that we know whenever we need, we know what real life hash, what's running on the system. Then preempt dynamic head, and that ate a lot of space from unit because now there was not only preempt or preempt, there was preempt dynamic. And that's only, I think, something like 64 bytes for the whole
exactly, yeah.
thing, which is not much. So we remove bit hash, we store it somewhere else in one version of info, and that's only /lp. But honestly, I'm not sure if it's something we want to have in our stream because of this.
Exactly.
Take a look at if we can somehow enlarge UTS name. I'm not sure.
Or maybe create a new field there. I know that this structure is shared with user space, so I'm not sure it's easy or feasible. But if we can have like another place there.
I just wonder if it would be enough to extend actually the information that is predicted by one host. So it provides the list of what it will do, and we might have other temporary just list of it like pitches, that might be more, and even show the state.
Yeah. Yeah, I think that would help, and that's one of the approaches. I'm sorry.
So I have a question for SUSE folks. It's just like, I think like if you patch uname, like that's probably going to change the behavior of other tools that depends on uname. And one thing I think that's going to break kpatch, because kpatch use uname-r to decide where to find the patches. And if you patch that, like that will change. So like depending on if you have patch version 1, like you will find a different location. But that's one thing I know, but I think there's other things that's probably going to break if we do that. So I want to know, like, SUSE's experience is something like turns out to be fixable, or
I'm not aware about any good like so.
So I think this specific issue you're talking about is where do we find the kpatch modules to load? Interesting question. I hadn't thought about it because I think we were also worried about changing the uname, disrupting any user space parsing of it. That might not expect the patch or a get hash present in uname. So could be here that SUSE has had development.
So, for example, if you're in the kernel tree, you do a module install, does that uname
Oh, there's a mic here as well.
Camera also, stand up too.
Just-
How-
okay.
the mic
Yeah.
is close.
So one hypothetical example would be if you do make modules install for a kernel, it installs it to libmodules, whatever, based on uname -r, right? So if you have a live patch loaded and you make modules install, that would presumably put them in the wrong place.
Yes, and I think that if we want to go towards that direction, probably we want to append a new field, and uname -r is going to report the same release. But let's say you have uname -l or k, and then it's dumped the KLP. Otherwise, I think it's like changing the kernel uname in the fly might have some consequences that are hard to debug. Anyway, thanks for the insight. Second problem, or second solution. As you said, maybe we can append that to warnings and bugs, or we can just append that to Net Console. We have like a dictionary. We can create this new dictionary, and we can append at every time that a KLP is loaded. That's not as ideal as the first one because that's just for kernel messages, but that's a solution, maybe eventually. And third proposed solution is we can create something like syskernel live patch active modules that is easy to read. So you don't need to do the whack-a-mole loading all of them and looking if they're enabled or not. Anyway, anything here seems crazy enough? Like,
Just regarding the last one. So I don't understand why those enabled attributes are not enough. So you don't really need active modules. You can go through enabled and that in each every patch. And
yeah, that's what we do today. But we need to have the same thing all the places, like to parse the directory. That if we have something like that, I think it's easy to read from user space first, and second, I think it's easy to read from kernel crashes. You don't need to do this parsing all the time. Let's say you have 3 modules, one of them is loaded, the others are not. That's my thinking. Maybe I'm completely mistaken here.
Just one remark. So we also had something similar. Not for modules. We had something for. We had a list of patches which were functions which were live patched on a system. That was kind of useful for us. It could not be in a sysfs because there's a rule for sysfs that each attribute needs or has to have only integer value. So it's either 1, 0, 1 or something like this. So we had it in a proc /proc, but that had its own limits because I think it's limited just by 4 kilobytes. Yeah, 4 kilobytes. So just one page. So we got in the situation where the list of functions was much longer. So it also didn't work for us much.
Cool.
Just saying.
Yeah, one thing that we actually have some small script that is able like to read the information from sys and just print the message. So I wonder if this might be a solution, like small tool
to print
that might be called and just print the status. And it might be called from.
The problem with that is like we cannot trust that too much because on the receiver side, then we need to keep state. So let's suppose you apply the module and then we remove it, apply the hotfix 1, and then remove hotfix 1, apply hotfix 2 on the others. And in the meantime, you have like a warning. So somehow here on the receiving side, you need to have state that, oh, now you have hotfix 1 instead of hotfix 2. And remember that we use Net Console. Net Console is UDP. We may miss messages. In this case, it's going to be like a total confusion.
Yeah, well, I still, from my point of view, I think that it's overhead to append this information to all printcar messages. And I still think that the best solution might be to add this to the warn output, because it's exactly there are these informations like loaded modules and a lot of stuff.
So, in your experience, at any given point in time, how many different live patches are making their way through your fleet?
How many, you mean?
How many different live patches are making their way through the fleet?
Making a way to the fleet. I mean, so if I have one version of the patch, I apply to 100 servers. Is this 1 or 100?
No. What I mean is, you said you had shards of this thing going on.
Mhm.
And as you go along, halfway through, if you found a bug, you would actually accumulate that live patch with the next patch. And so there could be distinct live patches currently making their way through the fleet. And the problem that you're listing here is because of that, right? After all, if only one live patch was making its way through the fleet, then you would know that
No, because you are comparing whatever is live patched with the pristine version of the kernel. So if you just have one, you want to compare this one against whatever was in the past to make sure that the version that you are hot fixing is not worse, at least, than the first version.
all right, I still have the same question, which is how many different base versions do you need to compare this new one against?
Let's take this offline. We just have 4 minutes,
All right.
and I think we still have like the
Yeah.
whole song section.
Okay, so couple things. And one thing, like we know live patch, like thanks Steve, makes the ftrace trampoline fast enough that we don't have to worry about it in most cases. It just works there. But when we have like millions of servers, like we got hammered for 1% performance drop. So we have to be very careful. So one thing is like, we keep getting asked, hey, you are patching this function. This is too hard that we're going to see a regression. So sometimes we don't have a good answer. And like, it's no easy way to say for different application, like how often this function will be called. It's like if there's some map or different things.
First of all, I don't know, did you ever implement to ftrace? I think we did. We switched to the ftrace args instead of using the regs. I mean, that should have made a significant impact improvement. So right now, I don't know exactly what the full impact is. Shouldn't be too bad because what happens now is it just jumps and then goes to your little thing and then jumps. So it's your little guy that needs to figure out what it is. I don't know if there's a way to shorten that. I don't know if, I mean, we could, there's a direct function call that BPF uses. I don't know if you want to use that, if that would make things more complex, more difficult. I don't know. The question is, if it's usually, how hot are the paths? And you guys can easily set counters if you want to know how many times it's hit.
Yeah, that's the point here.
Yeah. Oh yeah.
The point is not ftrace is not fast enough. Just it's like we want to have a vision or like a sense, like exactly how hot this is,
Right.
like how much actual overhead. We can have estimation like 100 nanosecond to 50 nanosecond, and we want the counter there so we can multiply that with the counter and have an estimation and easily tell someone show up and say, hey, I have a service. I think you have a live patch. We got a performance regression. Is that? We say, okay, you get this. You get a million calls per second. That's like nothing for your like a 100 core system.
Right.
So
the funny part is adding the counter will actually add overhead too. But
that is true. And that's
I know it's
exactly the
perseverance,
point.
but
Like we can always use tracing,
Yeah.
right? Like everything is ftrace both function. So we can always use tracing and count there. But like the counter is cheaper than add another layer of
Oh, yeah,
tracing.
yeah. No, I'm saying is, but I don't know if you want that counter like have a static switch or something to enable it or disable it. So if you don't care about the counter, you shouldn't be countering if you don't care about the counting.
Yeah, that's a
Because usually, like I said, when to me tracing or fly patching, to my point is you ideally want zero overhead. So sometimes I get overly micro optimizations, but still it's kind of like my view of tracing, and also I would say the instrumentation of live patch is the same. It's a second-class citizen to the kernel, which means that you basically do as much as you can to make it not impact what the kernel wants to do. So that's the only point I would say is yes, I would do that. I mean, it's up to you guys. It's the counter for your code. Do you already have the counter?
No, we don't.
So you guys don't have the counter yet. So, I mean, the counter will just tell you how hot it is, but it's not going to tell you the overhead of it.
Well, I think the overhead is actually
Yeah.
depends on
Yeah.
different architectures. Really,
And
like
cache alignments.
yeah,
and
I need to
it's-
have some estimation.
I actually put a bunch of trace points inside the scheduler and checked the overhead, and the Hackbench improved. I was like, wait a minute.
Because honestly, we never considered to measure any such thing because we knew that the overhead is really, really small, and especially with the recent sort of recent changes. So, and it was like it's always a question of balance. So I don't think it's just. So now you tell me. So you must have noticed it in your fleet. So or not. So
We haven't been brave enough to patch like a hot function of a scheduler or things like that. We pretty much every time we say, okay, this looks safe enough, and we just like sanity check, maybe with tracing, like just count how many times we do. And but
hot patch of the scheduler, that could be kernel scheduling plugins. Don't need SkidX, just hot patch it. Go on. So I'm sorry.
yeah, but that's
So, well, I think that actually interpret the counter is hard to do because it always depends what the function does. It might be huge function, and then the tracing stuff is negligible. But it might be really small function, and then the tracing stuff.
I think the counter is good because what you would do, I would say, is you probably have a timestamp. So the counter, it's not just a counter of how many times hit, it's how many times per second, how many times per millisecond.
Yeah.
So if it's the overhead is fixed. So even if it's big, because you really don't care, like, okay, yeah, this is a little guy, but it's only called a few times. It might double the length of the function, but since it's only called 3 times, you don't care.
Yeah.
But if it's a big function that's called millions of times, you'll notice the overhead on that one. So it's not the length of the function. I think the counter is actually the correct measurement of estimating how much this patch I did impacts the performance.
Yeah.
Can we disable and enable that at runtime, the counter, so we can do some sampling?
That's what I said. I said with a static, you could do a static branch. Are you familiar with static branches? Yeah. So just for those that don't know static branches, it's basically a live patch of the actually if statement. It's just it's a no op or a jump. So that instead of having an if statement, so you could actually do a static branch of whether or not you enable the counter or not at runtime. But then, yeah.
Yeah, I mean, why not? Because just could be hidden behind a config option or runtime option. So I can imagine to have something like this.
So it sounds like the answer is yes, implement it.
that's best.
Well, well, I wonder if you actually might measure the impact because you actually measured the system how it behaves like the next 4 hours, and I think that if there is some impact on the performance, you would see it in the output. So
yeah, I was going to say, for recent changes to the way ftrace call sites worked on ARM64, we added a bunch of benchmarks in samples where you can benchmark all the different ways the patching works. We should probably get some actual data through that and see, is there an overhead? Because there's things we could do to address it.
Yeah. Let me just show the last one so we can take it offline. So sometimes we have like KLP transition errors, and what it shows is it's kind of annoying, especially when you have like many servers, and they may fail different ways. So we have kpatch will print the stack, and there's a print debug in the functions that make the decision. We cannot do the transition, but that's kind of the debug is definitely 2 variables, and so I was thinking some summary. Maybe like at the end of like a transition failure will be really helpful when you have 1 million servers like making the transition, maybe 1,000 of them failed. You can quick summary.
Okay, yeah. Okay, thanks a lot.
Okay, so I think we can start, right?
Yep.
Okay, so thanks for Bruno and Salon and give a great introduction about what Meta is doing about live patching. So this is actually is the next step we are trying to do with live patching is a natural next step. And so the topic is KLP with a client LTO kernel, and which currently the upstream K-patch doesn't really support. So we will provide some kind of like experience we did hacking and to make it work, and then we would like to discuss and how we can actually make upstream to do it much better way. And I will present the first part and mostly related to how live patching is done and through a compiler perspective and LTO perspective, and some will discuss various issues we hit and what kind of hacking we are did. So this is a brief history of what kind of like PGO or LTO we are using over the time. And well, of course, we have much older kernels, but before the 5.6, and we use the GCC to build. And then we found basically Google published the PGO support, although not merged in a mainline, but it provided nice performance improvement. So we switched to LLVM with PGO for 5.12. We kind of like support both versions at that time, and just in case, and client PGO doesn't work. But it turns out it works. So 5.19, we fully use LLVM with PGO, and we also try to experiment with LTO and in the 5.19. That is experimental. We did various experimental experiments and with performance validation, and it does show LTO improves. And so for 6.4 kernel, and we actually try to use a PGO plus LTO. And so KLP for Meta, and you already get a rough idea and how KLP is used in Meta. We use the fork of K-patch and for our internal use. And but for LTO side, we need additional changes on top of that. And LTO and PGO both are actually not supported by K-patch. And so Sun actually has a branch and listed all the patches we did and try to support the PGO and LTO. And so for current status, PGO kernel already in production for 2+ years. And we are starting actually to roll out the LTO kernel, LTO plus PGO kernel. And currently, last week is 50K, and today actually probably will be more than that. So next few slides, I will briefly go through the LTO workflow and how KLP is involved. And this slide basically shows the non-LTO compilation workflow. I think for most kernel developers is much simpler and is well known. And you basically use a compiler, gen.o file, you use object2, do some massage, and do a linker and generate a vmlinks.o, and then you have this linker shell script file, and then you generate a vmlinks. And for the CDO part, and basically for the K-patch, and it's also well known, and you get before and after object files, you do a compare. You try to create basically the diff object based on the before and after K-patch object files. This is today already being done. And this slide shows the LTO compilation workflow. And the key difference is, and you first use clan, and you actually generate an IR file. Although, and the file name is .o, but it's not a L file. It's a bit code file, LLVM IR. And then you have this linker doing a lot of heavy lifting, and it input all these IR files and do a cross-file inlining, and internally it generates object file, and then the output is a single .o file, vmlinks.o, which including all the functions in the kernel. And then we do an object pool and do something, and we use a script and try to generate a final vmlinks. And so there's a problem here, and with the KLP and for this workflow, is VM Linux.o is too big and including all kernel functions. And we did experiments and with LTO, and it takes more than 10 hours, cannot finish. Actually, it is much more than 10 hours, and we have to stop, and we don't know when it will end. So this is a bigger problem. And so to work around this issue, we actually use a special, basically LLVM linker flag. LTO object path equals this prefix, and we dumped all the files, object files, and basically after linker and doing this cross-file inlining and generate internal object file, and before it final link to the vmlinux.o. So you can see now we get a bunch of files, actually vmlinux.o, .thing.lto.o, and number, sequential number, 1, 2, 3, 4, up to, I think, 2000 something object file. And so what we do actually is try to compare, and compare these object files and after linking, after internal object file generated by a linker. So you can see we have all these special named file, and we just, based on a number, compare and before and after Kpatch build, and generate the compare the object file, and eventually can do the work. And this is a roughly workflow, and mostly from the compiler perspective. The next I will pass to Sam, and he will describe so what kind of like Kpatch changes are needed and how we could do it better.
Okay, so I think we missed the one thing here. We need to run object2 on these .o files, and so far it works, and there might be some issues like in the corner cases. So this is missing here. So what do we have? So we first add the like what we described as thing LTO support, and so we don't do the create the diff object at IR level. So we dump the thing LTO, have the object file. That's what we described there, and we use that to generate the patch. That's the first thing. And second, we see the like LTO will use, because there's cross-file inlining, you attach the init call step that to the function that will make is to make sure that you don't have like duplicated symbol, and we need to detect that and ignore all those. And in the kernel side, we'll see like the LTO, the compiler will postfix some files with different things with LLVM dot something, and we update the Kpatch Mongo the string compile function to like ignore that, so we can actually find the right function. And so that's the next thing is the PGO support. And basically, we need to feed in the profile data to the compiler. We need to feed in the profile data to the Kpatch build. So the compile framework is the same. And we use the work from Google folks on like how to get the profile data that is required instrumentation, meaning we have a special kernel, we collect the profile, and basically we need the profile before any optimization for it to be accurate. And so far this work haven't got upstream because there's a concern about the requirement of a separate kernel to do the profile. And Hong is doing the work to see whether we can do alternative, like instead of you have a kernel, special kernel, use regular kernel, use perf, enable LBR, and whether we get enough benefit or whether that's good enough to as alternative of the training data we get, the profile data we get from the special kernel. But for now, because the kernel support is not upstream, to the K-patch build support is also not upstream. Okay, so the next is if there are changes in kernel, will be changes in the KLP build process. One of the things like the version timestamps file, I think that was added recently, and that's something we should ignore. Otherwise, we will get weird errors. Also, the PGO and LTO kernel adds all change different sections in the file. For example, that call graph profile, that's the PGO data is somehow is stored there. And the comment section shows the compiler you use to generate the ELF file. And if with the LTO, we may do the like cross-file inlining. So we see the case, okay, that comment section just growing with replicate like clowns 16, 16, 16, like multiple copies. And basically, we figure out that they are just safe to ignore, and we just ignore them. So we have the upstream discussion about LTO support, and so I think the overall the conclusion is like yeah, to be safe, we want to do binary diff with vmlinks.o, and which will not just solve LTO kernel, but together with IBT and other stuff will also be handled by vmlinux.o, because that's the eventually binary we run. We know that is accurate. And there's a different approach from Google with the LL patch, but as far as I'm aware, there's no recent work in that, so we'll probably need like more support, or we need a very good reason to make the switch. So next step, I think to do binary diff with vmlinux.o is suggested, and Josh actually mentioned he probably gonna work on that in the near future, but that's not so near path away.
Okay, so I'll start with IBT because I think this is something we really need to address. Is it? I mean, not only for K-patch, because, okay, so to explain, so now it works like this. So you, with CT-IBT, you get that special instruction NBR, like at the beginning of every range function. So that whenever it is called, the processor somehow checks that the instruction is there. If not, there's an exception, right? So OBJ2 currently seals the kernel, which means that all those instructions NBR which are not used, so that meaning that those functions are not used for indirect jumps, am I still correct? Yes. Then those instructions are removed. So whenever it is used, then there's an exception in kernel, which for our case means that whenever we like to live patch such a function, we're in trouble. Are we not?
So the exception is if the ENBR is missing.
Yes.
Right. So if you just always have the ENBR, don't seal. I mean, that's the easiest solution is always have the ENBR in your replacement function.
Should you live patch the destination and have an NBR there?
But
if you're live patching the caller, you're saying this, you might the caller might now indirectly call someone that's been sealed.
I'll give you the mic.
Stand, please. Yeah, so sorry. If you're live patching a caller and they're going to now make an indirect call to someplace that's been sealed, so the NBR has been removed, you have to live patch them as well, right? You're live patching two functions now.
If you're adding an indirect call, yeah.
Yeah, you reply. Yeah, I mean, yeah. Back to your simple solution. So you thought that we would just disable the sealing?
Or, yeah, maybe don't seal the replacement function. Just leave the ENBR. Or if the original replacement function is sealed, you can check, there's a way to check whether or not it's going to be sealed at compile time. So that's another option. Check OBJ tools metadata about which functions are sealed or not, and then do the same thing for your replacement function. And that could be automated.
Yeah, right.
Especially if it's OBJ tool doing, for example, KOP convert, if that were an OBJ tool subcommand, that would, OBJ tool already knows things, so maybe that would make sense or something, you know?
Yeah. Okay.
But yeah, the thing that Nick mentioned about adding an indirect branch, that could complicate matters.
Yes.
You would have to patch the one that doesn't have the EMBR that you're indirect branching to.
Or maybe we just inline the function to whoever calls it, and just patch those.
Yeah.
But that's, I don't know whether kpatch build, I don't think it does inlining.
Well, you could do always inline in your
Oh, in the
patch.
patch, oh yeah,
Yeah.
that's.
Yeah.
One of the things we do in Zen for this is because you end up having you do need to replace functions that have been called indirectly, but you can do that just by having the end branch and then a jump following that, so long as you are willing to modify different parts of the code. So even with fine IBT, a lot of the safety primitives for that will still work if you have room to patch in an unconditional jump at the top. In that way, you can still end up with the same sealedness of your original and the replacement. You can just look at the one you're replacing, see whether it's sealed or not, and do the same on the destination. At that point, you're using direct branches, and so your indirect branch hits the old end branch instruction, and the new target skips past it into the destination or into the new replacement.
So back to the kpatch build question, because that's a different concern, right? With the VM Linux takes forever, you know. So yeah, I think for IBT and LTO, I agree. We're kind of at a fork in the road. Do we work on kpatch and hopefully that we can, you know, get it to deal with VM Linux within a reasonable amount of time? That's definitely an option. We don't know how quick we can do that, but we had similar issues with OBJ tool. It was really slow with VM Linux, and now it's reasonably fast. So that's one option. Another option is, like you mentioned on the previous slide, like, are there other options? You know, there's LL patch, and there's what SUSE does, right? So something we've always talked about is what's the best way that we can all agree on to make live patches. So that could be another thing, is finally figure that out. And if it's not kpatch, then we can just do something else and not have to worry about this problem. So.
To explain, we at SUSE, we prepare live patches from sources, right? So that we don't do the binary difference. And we have some internal bespoke solution which does the code closure around a patched function. And now we also looked into how to use Clang extract tool, which would do the same using LLVM IR representation. So that might be the way forward in the end.
So that's actually my question, like before the micro conference to Susie folks. And do we see we're gonna have one day have 1-2 chain that works for everyone? And but I guess the answer I get is like we don't think that's gonna happen.
Well,
in the near future.
But it's not the case now. It's something I really like to have in the future. But yeah, that's how it is.
Maybe the to-do list for next macro conference.
Okay, so we have still 5 minutes. So are there more comments, questions? Okay, so if not, yeah, okay, so there's one.
What's preventing you from testing out the PGO with like sampled LBRs? I believe we have this data already.
Yuhong is doing the test right now.
Oh. Oh, sorry. I was asking about doing the PGO testing with samples from LBR.
Guys, the rules in baseball, you don't throw the baseball till they put the glove up. It's okay. So we had this discussion like when we sent the PGO patch set upstream. It was like patches themselves didn't get nacked. The pull request to Linus got nacked. And we said why should you do instrumentation versus sampling based? Because both work. We have them both working, right? And the issue we have with the sample based and LBR is like everything works great on Intel. So instrumentation is, a little bit more flexible if your fleet is a little bit more heterogeneous. But, I think Ingo and Linus were both like, well, why don't you push all the vendors to just implement LBR and then the world will be great. And we're like, okay, but even if we did, that would take years. So can we please upstream the instrumentation patches? And so I think now that multiple people are carrying the patch set forward out of tree, we need to go, can we please upstream this? Because now people are shipping out of tree like forks in production. And I think it would be better for that to at least be in the tree. And we can still apply pressure on vendors to get something from perf where sample data just works for people. Whether or not that's LBR, I don't care.
Just want to get a little bit of clarification. And actually, we do have some experiments with sampling based. And so far, and initial result is sampling actually a bit worse than PGO. And some percentage worse, and still need a tuning and understanding, and whether it's a compiler issue because it need to map this, the instruction to debug info and back to source code. That's a long journey compared to the PGO. You immediately have a code there. It's really clear you are correct. So there's still something need to be done, and in the sample based. And it is a little bit more complicated, actually. I'm pretty sure Google has done some work to make it better, but we just started, and the performance results actually, and shows we have a little bit more work need to do. Yeah.
Okay, so we still have 1 minute, one comment, question. Okay, if not, thank you.
Thank you.
And next speaker is, Lukasz.
Okay. Yeah, I mean this one. Ah, okay, yeah, it's here.
Sunday night. Did you have that? Yeah, I had this.
Okay, may I start? Yep. Okay, so hello everyone. My name is Luka Hruška. I work for SUSE, as a kernel live patching developer. And the topic I would like to discuss today is cable support for KLP relocation generation. Now, why do we even need some relocations? It's because live patch is not some standalone isolated module. It needs to reference some symbols, and also in case of having exported symbol, we don't want to be dependent on some module. We just want to dependency on the VM Linux itself, and that's all. So the symbols could be global, and even the exported one in case of the modules, and even non-included local symbols. Now, because of the callsims lookup name function was already unexported, we cannot currently resolve this issue by our own in the live patch module itself. And the only way how we can solve this currently is the module loader's special format of the ELF for those live patch relocations, which requires some non-trivial modification to KO file. So it's not possible to do it just from the source code or just using the object copy tool. And also because we need to do those modifications after running the mode post, we need to modify the mode post itself to skip allow unresolved symbols in case of we are running it on the live patch module. Now, to better understand the next slides, we will first take a look on the known relocation in the user space and compare them to the expected KLP live patch relocations, where in the user space we have some sections with some specific prefix rela, and then after that we have the section name where we want to do those relocations. Then there are those entries where the offset is the offset inside the file in the binary where we want to do this relocation, and the symbol name which should be solved during the linking time. The live patch relocations is really similar. There we have a bigger prefix where the KLP indicates that this is a section which is going to be resolved by the kernel live patching. Then there is the rela section and section name, which is absolutely the same as with the user space. And only thing which is more there extra is the object name, which indicates the name of the object which we are trying to live patch, which is using those symbols. So that way the module loader will create the notifier, and after loading up this module, it will do those relocations itself. Then those section entries are also similar. We have this prefix KLP sim, which is the same as the KLP prefix in the section name, just indicating that this is going to be resolved by kernel live patching. Then object name, which indicates where the symbol we are trying to look for is located, in which object. Then symbol name is same as the user space, and the extra which is there is the symbol position, because we might have multiple symbols with the same name. So we need to specify which one we want. Now, to solve this, there is a proposal for the tool called KLP Convert, which history starts in 2016. It was sent by Josh, where we have a macro KLP module reloc, which is moving the tagged structure to section with specific name, which then the tool looks for and do those transformation on those data. The mode was modified in a way that it's keeping all unresolved symbols in case of finding a live patch string in modinfo. Then there is version 2, which was sent in 2019, where functionality which is able to automatically resolve the relocation symbols on its own was introduced. And also in case of having multiple symbols with the same name, there were it would print out all the possible information about the symbols and their positions, so you can then specify it by the macro KLP symbols manually. Then version 3 to version 7 didn't introduce some new functionalities. It was just solving some edge cases, bug fixes, and styling. And now we have a minimal version, which Nikolai Sange proposed for in the version 7. And it's based on the version 7, where I just removed the automated KLP rela creation, like the automatic unresolved symbol resolution. There is another macro KLP rela symbol which creates, which not renames, but yeah, it aliases the tagged variable by the format you can see there, where the KLP sim_rela is a specific prefix which the mod posts now only allow as an unresolved symbol in case of having live patch module. Then we have the LP object, which is the module we are trying to live patch. Sim object is the object which contains the symbol we are looking for. The sim name is the name of the symbol, and sim post is the position of the symbol in case of having multiple of them. Now there is an example that how does it work. You just simply append this macro after the definition of the variable, which then creates this rela symbol with all window format which I already described. And after running the KLP convert, it is in the expected format as we looked for before. Now some discussion. So one of the questions would be why this tool is still not upstreamed. And also, is the minimal version which I sent last week is enough for everyone? Also, what would be the future of those self-tests in case of not having it part of the K-build, or at least part of the upstream? And if we should, if the KLP convert should be part of the K-build or not.
Yeah. So I think the reason it's not upstreamed is it just, right now it has one user or one potential user. I think, so just one user, why do we all need to support it? You know, I'm not against KLP convert. I did write the original version. And maybe that's the future, like converged patch, you know, thing that we were talking about, patch creation tooling. So yeah, I mean, if I think the big thing that was missing for me was the documentation on how to do an end-to-end live patch that's not going to blow up occasionally because of intra-procedural optimizations that you missed or whatever, right? So that whole like end-to-end process for me would need to be documented in the kernel tree. So here's how you make a live patch using KLP convert. Then for me, that would be enough.
Yeah, okay, I understand. I'm not in disagreement, but I think that one of the advantages, I'll start differently. So currently we have this relocation infrastructure in the kernel, which is not tested at all. It's just tested only by you and Kpatch, if I understand correctly. I think that this minimal KLP convert tool would at least allow us to have self-tests for exactly this. So suddenly we would be able to test it even in the kernel properly, like we do with all the other things we provide as part of the infrastructure. So it's not like, I mean, I see that suddenly we move, with this minimal version, we move from something which might be part of the whole live patch creation process to something which is enough to use as part of our testing infrastructure, and also can be used later or by you. I guess that would be my other question. If this is something that you can migrate KPatch on, since this is really minimal. So you would just use, because if I understand correctly, you currently use some KPatch relocation section to gather everything, and then you just generate it properly. So maybe you could use this, not to generate these, but you would have those special macro thingies.
Possibly.
And yeah, so which might be also beneficial for you, that suddenly you would not need to maintain something which is out of 3. So those are my 2 points which this might be now ready, and maybe it's not needed to wait for the whole big thing. Just my 2 cents. Yep.
It's not awkward, but Josh, I think I would probably echo his point to the self-tests. I think we recently had a patch set from Song, right, to, I think, clear KLP relocations. And as the person that had to test it with KPatch, it would have been a lot easier if we just had in-kernel self-tests that could do that. I think they were part of some of those version 3 to 7 improvements that were made.
Is the self-test immune to intra-procedural optimizations? Or
no.
Okay.
It's just to drive the kernel API. It's not.
So it could, in
Definitely
theory, blow up, and it wouldn't be necessarily a bug in KLP convert, right?
Theoretically, yes, but if we're careful enough, because I mean, the whole self-test, the module is really of a limited scope, so that's not like something which lives in the wild and you use every day in your production live patches. So we have it under control, so we might use, well, the worst thing which might happen is that, yeah, it will be influenced by some of these IP optimizations which are not, let's say, allowed, but maybe we can just disable them using function attributes or something like this and be done with it. Yeah, I mean, yes, it's not ideal.
But another concern I have is that, I mean, I agree it's a great benefit to have the self-test to test KLP reloads. But a worry I have is that people will see the self-test and say, oh, how do you build a live patch? They see the self-test, like, oh, look how easy it is. You just use KLP convert and it's so easy. And then they do it and it blows up in their face after they've used it for several months. They're thinking this is how you do it. Then they get that IPA and, you know what I mean? It gives a false sense of security or safety.
Okay, so I'll have Petr reply, but I think about it.
I think that or that we definitely could make it like, it would be nice to have all this infrastructure to make it more safe to create live patches, but the question if it ever will be like that we could automatically detect that some things can be live patched a safe way with what we have. I mean that is for example KPatch like error proof, like that it can pass anything.
Oh,
yeah.
Do you mean KPatches makes it look like it's safe if you just put any patch into it? Yeah, that's a valid point. Yeah. Like, yeah, so live patching is not like something to be taken casually. That's a good point. Yeah.
Actually, for the live patching, we need to disable a lot of IPA optimization for the program first, right? Yeah, in GCC we add an option for the live patching, especially that's dash F. Yeah, I added that one.
Okay.
So I think it's already disabled all the interprocedure optimization that's interrupt with live patching.
Yeah, so that's what SUSE uses.
Okay.
But for the K-patch, we do a binary diff. So we're not, so even if there is an IPA optimization that the patch affects, then we'll just patch both the caller and the callee so that it's not an issue.
Yeah.
But yeah.
There shouldn't be an issue, right? No.
So there's an issue. So when we enable -f live patching, it breaks OBJ tool because suddenly many more unreachable warnings appear, and we aren't really able to fix them.
So
I
you
mean,
mean
generally.
you cannot use the live patching option? No? What's
Sorry, could you repeat it, please?
So what do you mean when you add the live patching options? What kind of issue?
Okay, so the thing is, so that when you enable this option, it disables some of those, let's say, dangerous optimizations.
Yeah.
And then when the kernel is built, then some OBJ tool warnings appear because suddenly the code is a little bit different, and there are some unreachable warnings of OBJ tool. And we don't have a generic solution for that. What we do is that whenever we upgrade the kernel for our enterprise Linux distribution, we just go through those warnings and just say, okay, so there's nothing suspicious because those are really false positives given by this option. But that's just like not ideal as well. So we live with it, but there are more issues too.
Yeah, so I wonder if we could collaborate and look at those. Maybe it doesn't quite, some old optimizations aren't like completed, so it leaves some instructions that can't be executed, and so OBJ tool flags that, so maybe we could look at improving that.
Yeah, that might be some bugs. So I think, if you can file bug on that, I can take a look to fix whether the live patching option can fix this kind of situation. Yeah. Yeah.
And there was another concern we had with F live patching was that we have config live patch enabled on some distros, but many users don't use it. So what would be the performance impact for those who don't need that?
Yeah, that's quite some performance impact because it's disabled most of the IPA optimization. Yeah.
Right.
But if user really want to enable the IPA optimization, then we cannot do live patching, right? We cannot do live patching because most of the IPA optimization will interrupt the live patching. No.
I don't think that most of IPA
Many of
optimizations are disabled because we disable something like IPA RA which is clearly dangerous.
Yeah, I think the most important thing is inline.
Yeah, but that's not disabled. Okay, so it's
inline is the most important optimization.
Yeah, it is, but it's not disabled. Okay, so there are two options. -f live patching gets inline clone or something, and we use the one which doesn't disable inlining, constant propagation, SI and stuff like that. That's still there. So it just disables some really limited scope.
Yeah, crossfire inline, we need to disable it. I think there's a two level of the option.
Yes.
Yeah.
So so the performance impact is not that bad because the kernel is a different thing that most of the user space programs does. So it doesn't use so many weird, let's say weird optimizations because we use different weird optimizations.
Yeah,
but, yeah.
I remember kernel's performance seems not rely on the crossfire inline too much. Yeah, we have some data before to see whether disable crossfire inline, how much the performance impact to the kernel. Looks like it's okay. Yeah.
Yeah, we did some measurements way back, and it was acceptable. I don't remember anymore, but it's like really.
But if you do see any issue with the live patching option, then just file back on GCC. Yeah, we'll take a look and fix it. Yeah.
Okay. Thank you. Carlos, would you want?
No.
Yeah. Oh, okay. I thought you.
I love this talk. I'm here to make sure that if there's anything that we can do, we can tools you.
Do you want?
Yeah. No, I'm just watching and listening. I'm here just to hear if there are any tool chain issues that you think need to be fixed, but I want to echo just file bugs. If it actually ends up being instructions that are unreachable, why are they there, right? Like we don't want to omit them either on the compiler side. So if you can file the thing that got omitted and why you don't think it should be omitted, or even just a warning. So it makes sense. So
yeah, because this goes to the whole big topic of fixing those unreachable things. So it's not like, I mean, not only for live patching, but for OBJFlow generally, because there's currently no, if I'm not mistaken, there's currently no way to do it properly, because we have OBJFlow has a list of functions which are then ignored. These unreachable, so that, you know, we mark them as false positives, but basically, and that's it. And it would be nice to have something generic, but that's
Bunch of those I know ObjectTool has workaround for. I know on ARM64 we got potential issues around no return functions and ambiguity for unwinding. So I think there's probably good scope to have a talk about exactly this shape of issue. Not necessarily now, but next round.
Okay, so so there are more questions, of course. So, yeah. The last one, should KLP convert be part of KBuild? Because currently it is. It's always been. But there's also a possibility not to have it, because I think that that KBuild integration part is the scariest one. So there's also a way to call it manually, basically, on the result. So that might also be a way. I don't have an opinion. Joe, if you want to.
Repeat the question really quickly.
So the question is whether we need to preserve this cable integration or.
In the kernel build itself.
Yes.
Most convenient. Keeping it in the kernel build, I mean, it seems most convenient. It's in one place. I suppose nothing stops you from having it as a outside of tree and run it separately. Then you're kind of back in the same position where you have this thing over here. In the case we had Kpatch build that was creating these relocations somewhere else outside the tree. That said, I think integrating it into the kernel build is probably hardest part for me when I was working on that patch set. It's so completely different than any live patching kernel code. It's amazing.
True.
So what would you do instead of integrating into KBuild? I mean, yeah.
I mean, it's a possibility to have KLP convert hidden somewhere on the scripts / and so to use it like you would build out of tree live patch module with, you would still need that patch in Modbase so that it would ignore those unresolved warnings, and then you would run it manually.
And also
like,
just to build the samples.
It's not great, but at the same time, you can integrate it well to your some downstream build system easily. So that might also be an option. I don't have an opinion. If KBuild integration works for the maintainer, then yeah, that seems like a no-brainer. But
yeah, I don't know.
Okay, we still have some minutes. Are there more questions or comments?
Sure. I think in the early slides you said this was based on the 7th version of the patch set, and I was curious, did you look into changing anything beyond the macro that was generating the relocation name?
I just removed all the loading of those, how is it called, the symbols list, all the
scary parts.
Yeah, exactly. Just made it simple main file, which is just checking, these sections which I'm looking for with this prefix, and then just modifying them and renaming those relocation sections to what I want. So I just kept like 3 functions there, and that's all.
Okay. In the course of going through and using the tool, did you have any thoughts on, I think in my experience, it was possible to generate relocations that end up in kernel or module sections like that, like .init or read-only sections. And in the case of everybody's favorite live patching feature, the late module patching case, the module has already been loaded and finalized, and protections on sections and memory have been made. And the KLP relocations show up with a potential way to modify things that I think kernel had assumed would never be changed. I remember asking these questions, I think, in some of the earlier versions, and nobody had a great answer.
I think the shortest answer is I didn't think about it.
Okay. All right.
So maybe this is a question for the tooling above the KLP code then, because I mean.
Right. So I could generate a module that builds with no issues with macros, at least version 7, and then when I loaded it, and these KLP relocations were resolved, it might depend on the architecture. In some cases, x86 would be happy to update and set this KLP relocation. But then PowerPC had a different idea. Like it thought, oh, once I finalize that module, it's done. No one's ever touching this init section again. To be fair, I mean, I had to really think about how to artificially generate it. So it might not be like a real world case, but at the same time, the compiler will generate it. So I was able to crash kernels.
Yeah, it's definitely something to be aware of.
I was resorting to an allow block list, sort of saying, well, I know that these are sane relocation just to put in these sections. These are not, and I guess in my mind, I'm thinking from a K-patch build perspective, where you have patches and you kind of have a limited sort of set of these relocations that you're generating. You're not typically trying to specifically pick these problematic, like read-only kind of things.
Okay. More questions? Okay.
Just curious on the previous conversation you guys are having. Is this related to is this the issue about the compiler generating some code with the F live patching options and then OBJ2 having some problem with, is this a problem in the way the code is generated, or is this more like some limitations because of the way we try to, recreate the control flow graph and not being able to decipher where it's on the other side, which is.
Yeah, it was a problem with the code generation itself.
Mm-hmm.
Yeah, there were some instructions left over that weren't possible to be executed.
Okay.
They were just kind of stray instructions. It didn't affect anything really, it just made the function slightly bigger, and that confused OBJ tool because it thought maybe it lost track of the control flow because there's these instructions that weren't that can't be executed.
Okay, so thanks a lot. Now there's a coffee break, so see you in half an hour again.
Let's do the questions. Yeah. It's about self-test. Are those the ones that were in the subset, or are those already in the tree?
Just created a separate GitHub project where I was posting.
Sorry, you were saying, you use No, no, we add this for the, yeah, so we use it in our issue. So that's added maybe 5 years ago. So, they have a workflow and the compiler valid expectations. The compiler can generate arbitrary instructions. And they go, no. And whenever you get an error like that, you're like, let's have a conversation. Right, like, it's not really a optimization. There can be some like you can never reach. That is just quality. Yes. Contract would never agree. So, I say that the expectations. Yeah.
Now I understand. You're wrong. From our perspective, from their perspective, they say, you used to generate from that stuff. Now, but we never promised you what they were doing. We just need to turn on.
Okay, so we'll come back and we'll start with Beto giving a talk about KLP states.
So, hello, my name is Petr Mládek and I am kernel developer at SUSE, focusing on live patching and printk and other stuff. Yeah, and today I would like to talk about how to better integrate some extra features provided by the live patching support in kernel for the live patches. So, yeah. Let me first explain what these features are about. So, like the basic functionality of live patches is basically to redirect the buggy functions to the new code that is included in the live patch module. That's the basic infrastructure and sometimes functionality. Sometimes it's not enough. Sometimes it's needed for the new code to actually work to, I don't know, convert some data or create some extra data or, I don't know, create some new text or whatever. And for this, there are 4 callbacks, where one is called before the live patch is enabled, the other one at the end of the transition when all processes on the system already are using the fixed code, and the other are basically reverted when the live patch gets disabled, before and after. Yeah, then there are shadow variables. It's an API which allows to allocate some memory and associate it with some address. And another API allows to get this data for the address and so on. And the problem was that actually these callbacks and shadow variables might be used by more live patches, either when they are installed in parallel or most users are using that atomic replace. So the new version actually would want to do the same changes, but it doesn't have to do when the previous live patch already did the changes called these callbacks. Or regarding the shadow variables, when the new version might not longer use this. So actually, the shadow variables should be freed because they will not longer be used. Or when there is a downgrade, that they should be released as well. And so this was not well supported. So we introduced KLP states API, which allows to define like states with some ID, and an API that the callbacks were able to check if this state was in the previous, if the current live patch, or if they exist in the new live patch that is being enabled, and so on. And now let's see how these are integrated. I try to show it in some pictures, how the kernel core knows about this. So when the live patch modules is installed, then it actually passes some structure with the live patch data to kernel by this KLP enable patch function, and this structure contains array of structure for objects which split the live patch functions for VM Linux and other modules that might be live patch, because the redirection has to be done when these modules are loaded. Then there are this structures object contains array of structures functions that provide information how to do the redirection. And then the original callbacks were also part of this structure object, so that we could have custom callbacks when these live patch modules are loaded. Then, then the states, when we added the states, then we decided that the callbacks in the modules objects were not were used rarely or not at all. So we decided to simplify things and put the states just as an array into the patch structure. And I missed that there appear actually shadow variables, and the kernel core is not aware about the shadow variables at all, because there is just API that is used by the callbacks or by the fixed versions of the functions that they allocate and get this data and so on. So actually, you see that it doesn't the states are not well fit together with the callbacks and even the shadow variables. The problem with the shadow variables was that if they are not longer used, that the core couldn't free them, just do some garbage collection and so on. So we could do better. And so it took some discussions, and we came with this proposal to have the structure patch, structure objects, and keep just the functions in the structure object. And then move the callbacks into the structure state. And actually, it won't be possible to call them when the live patch module is loaded. We will have just callbacks when the state. And also, I proposed to change the semantic, or we proposed to change the semantic so that the callbacks will be called only when the state is introduced or when the state is not longer used. So it will be pre-transition and post-transition, but when there is the atomic replace and the state was already there and still will be there, then nothing will be called. And another state, it will be actually, we could mark some state that it's related to some shadow variables. And also the shadow variables were distinguished by some ID, and also the states had some ID. So basically we could use the same ID for the state and shadow variables. And so if the new live patch doesn't longer support this state that was related to shadow variables, then we could do simply the garbage collections, even the core. And before, it had to be handled by some callback that had to check that the state was not longer supported and so on. So it was really complicated. So that's it. Here is the summary of the changes that just that the callbacks are actually during the atomic replace. We currently call the callbacks just from the new live patch. and it's historically because it helps like partly with the semantic, because if both patches, if the old package calls this unpatch callbacks and the new patch calls the enable callbacks, then they would maybe mess with each other. Then one would disable the same things and the other one would like to enable it, and so on. So it would create problems. So actually, and as a result, the downgrade was not easy because the old patch didn't have these callbacks to basically disable what's not longer supported. But newly, it's about the state, so we could basically call the callbacks from the state structure, so we could call them even from the old patch when the state is not longer supported, because and the old patch need these callbacks also because when to support disabling the live patch, it's basically the same. Downgrade or disabling is basically the same operation. Yeah, then the garbage collection of shadow variables is simple. And also originally the states had versions which allowed to maintain kind of compatibility. So only live patch with the same states and with the higher versions was able to replace the old one. But basically in practice, it's just use that when the live patch, when the changes done by the callbacks are hard to revert, or maybe they're even impossible to get revert, or the author of the live patch don't want to spend time with supporting the revert. So in this case, we could replace the version with just simple flag like blocked, disable, and it will block downgrade and to live patches that no longer support this state, or block disable because the code is not implemented. So at the end, I think that it makes perfect sense, and it all fits much better together. So the limitations are that actually the callbacks won't be, will not longer be callbacks when the live patched module is loaded. But the question is if we want to keep them or not. The idea is that actually even the live patch might register their own module notifier. And actually, it's much easier to do these changes when the module gets loaded, because actually we might do the needed modifications before the loaded module gets activated, because before it calls module init. Because before calling that module init, basically the kernel should not be aware that it's loaded. So there is no need like the pre-transition and post-transition. And the same is that we could revert these changes after calling module exit, because after this, the kernel should no longer use any functionality from that module. So we basically don't need both callbacks. And another thing that actually, and it's missing on the slides, is that I wonder if we sometimes might need some callback for transitioning this state, like even when the new live patch is still using the state, that I might need to do some action to actually take over the state. But I'm not sure if it would be useful in practice or not. Yeah. Yeah. But it would make the semantics maybe more complicated. I'm not sure if it's worth it.
Yeah, I would propose keep it simple to start with, and then if we have these edge cases, then we can always iterate later. I had one question. So when you associate a shadow variable with a state, is it you can only associate one shadow variable? Is that right?
Yeah, well, it's basically not associating like the data with the state. It's basically just associating the ID. That the state ID will be the same like shadow ID. And I implemented the proof of concept, and there is just when the kernel is disabling the live patch, and or when replacing, and the new live patch doesn't longer support this shadow variable, this state with shadow variables, it automatically frees. Does the garbage collection just by calling a shadow variable free all. That's the name.
Yeah, so is that the common case where you only need one shadow variable type for a set of callbacks and for a state? Or is there?
Yeah, well, we would need basically one state for each shadow variable ID, because like the ID defines kind of the type. For example, if you are extending the structure, then you need instances of the shadow variable for each structure if it exists more times. But like
So the patch could have multiple states. If it had multiple shadow variable types, it could have one state for each.
No.
No.
It would mean like for every, well, no, like you have to distinguish like the shadow variables instances, like the data that are allocated, and that ID of the shadow variables. That ID kind of means the type, or
Right.
We could see it as a type, like this shadow variables is for adding, I don't know, some counter into some structure.
Right. So.
And the same counter might be, yeah.
Right. So if one patch needed multiple shadow variable types, it would need, and it wanted them to be garbage collected.
Yeah.
It would need one state. You need multiple states. One
Yeah,
for each.
multiple states. It's just because we need to remember the ID of each shadow variable.
Yeah.
And yeah, it would be possible to make the IDs like list of IDs, but I think that this is.
And even if the state didn't have callbacks, it could still exist, right? Still exist for the sake of the shadow variable type.
Yeah. We could create just state without callbacks, and say that this state is for this shadow variable ID, and will be used just for the garbage collection, and it will actually save. Otherwise, we would need the callback just to free them. Yeah.
So from my point of view, this association between shadow variables and states is like only convenience, because you could achieve the same by implementing callbacks freeing the shadow variable you like, and any number, of course. So yeah, it's just.
Yeah, and I wonder if actually this changes basically the API of the live patches. So I wonder if it's acceptable for people using.
It looks good to me. I like it.
Yeah.
Are there more comments or questions? Okay, so thank you.
Yeah.
And now let's wait for the top of the hour so that people get a chance to join next talk.
Yeah, I'm really like it. Okay, so I mentioned the share notes in this DB thing.
I'm just writing them in the file and look at them there somewhere next week or so.
Send these to someone, right? That we need to kind of saying where we had control with the others, and the way that we were managing guidance. Something. I'm sure there'll be a lot of red tape required afterwards.
Do you think so? Do you think anybody would even look at this? I mean, beyond is there
That's not the
probably
point.
not.
That's not the point. I mean, on one side, you get something which is useful, and on the other side, you can it's required.
Yeah.
What if we don't need
I don't care. What other trick do we? What are you trying to say? Tell me.
Yeah, we also have like new script, it's in Python currently on top of the that actually integrates all those like well, it's partly like this was check out all this like get download all this RPMs with these kernels that we need to prepare like patch code because they like make for all the supported kernels. So then it checks scheduling functions like versions
It's all kind of added.
Yeah. So we could describe this like the first year basically did it maybe 2 years we didn't do that. This as the number of supported kernels released.
Salaries and
yes, like
and then the tools are not like usually at least if it's written down like here's how you use convert. Then maybe others would say, hey, I just try that, and that would make the tool grow from that, even from scratch.
Yeah. Yeah. I feel we don't have that. Another problem is that like used to be very small just but I was working on other stuff and it was
I'm not, I don't think, I'm not.
So, yeah.
Basically, like, I like your.
Yes, exactly. And it's only thanks to this microcontroller. Realizing final time to do work, so it's just
Just when I said that like this summer there were several like CDs that kind of schedule variables and code
will modify the upstream patches so that they can be safe for
You look just looking at the overwhelmed at the SUSE branding template. It's like really. I'm sure that spent videos. Yeah, several times.
So do you like
I think it's gives you a coherent sort of structure, and I think it leads you to treat like a series of patches. I think that will stay frame and then connect there. One of the cases that we pushed in so interesting
was an easy one to take minutes for. Like, yes, with this.
Doesn't spend so much time just before what it was
on the presentation, on the implementation. Yeah, I've seen the patch. Problem was you can do anything about it. Check mark. So there was success even before the conference had started. I just saw that.
Yes.
It's usually all over the kernel.
Yes.
Say that today, maybe like next week. Bluetooth or net filter.
Sorry?
Yes, disabled.
So it's complaining that the CD is still so
Oh, it's really. I mean, so I mean, in general, all these lifetime issues. I mean, you know, it are like require a lot of rework of the upstream patches. And my hope is that what Peter is doing is really helping that, because you can just really use shadow variables and be done, but don't think more about it. And right now we're really doing. I mean, we really have to understand each issue, find an alternative solution.
Some exciting new subsystems.
And it takes a lot of time because, I mean, what do I know about net filter or stuff? So net filter lifetimes. So, yeah. So.
The module is like allocate the same exposure to zillion places.
I mean, even getting familiar with these structures, the subsystems like chains and rules on the chains. And
I'm happy to say that.
Still have some minutes, right?
Yeah, lucky you.
Oh, that should be after our discussions Okay.
Right? Just one.
Hello. My name is Marcos. I work as a kernel live patch developer for SUSE, and today I'm going to talk about moving our self-tests for live patch into case self-tests and the obstacles and problems that we found in the process. So this is our agenda. So talk about case self-tests, what it is, its goals, and how the tests are run today for our live patch self-tests. The problems that we found when trying to move the tests to case self-tests, and our proposal to solve the problem. What's case self-tests and its goal? So case of tests is designed to exercise exactly some exact code paths in the kernel, and it has some, not restrictions, but some ways to work around that. So it only accepts user space tests, but there is a kernel module, the BPF1, which is big inside, but currently the rule is to only accept user space tests. And this user space, they are divided into some shell scripts, bash and stuff, and some user space programs to exercise syscalls and other general verifications. And case of test has some useful targets, so you can run on the top level dir using make case of test targets. And you also can pass more than one, but we are currently using the live patch. And whenever, okay.
Just to relate to just about the user, I mean, only user space tests. I mean, there's BPF module. Ftrace uses modules. So the self-test actually checks, is this module loaded? I'll run the tests. So we actually have test modules. So it's not totally strict. It's just that you can't fail the test if it's not there. You just say unsupported or not.
No, I mean the test, the code that tests the modules, they live inside case of test, but they only check if the module is loaded, right? But the module code lives outside case of test.
Right.
Yeah.
Oh, that's right. Okay.
Yeah, that's what I meant. Sorry.
That's right. I was a little confused by that.
Yeah. No, yeah, that's because we want to try to move code inside case of test structure for our purpose that we'll detail after all. So yeah, there's some targets just to run the test and to do some other stuff. And every new subsystem that applies to case of test, they need to comply with these targets. And there is also the Gentar target for self-tests, which packs all some different it packs some self-tests like live patch, BPF and stuff, but it only packs binaries. So I asked on the mailing list about the purpose of the Gentar, and yeah, I didn't receive a direct answer about that, but it currently only packs binaries. So how to test these binaries in different systems? Yeah, that's an open question. Yeah.
Thank you. So this is a question to the audience. Is here anyone who knows what Gentar is for? How is it used? What's the reason it lives in the kernel? Can we just get rid of it?
Yeah. So is that something self?
Does someone remote?
Oh, Mark Brown. Yeah.
Yeah. So I was going Gentar is used by automated systems. So when they build the self-test as part of the kernel build, and then they want to deploy it onto a target system, so they take the tarball and ship that around.
Okay, so do you know, are there some requirements because so you build binaries on some system, you pack them, then try to deploy them on some other machine. So are there any requirements about libraries being present if they are used for the self-tests?
I mean, they will need to be present, but the expectation is that the people running the tests will sort that out. I mean, there's already extensive reasonably substantial library dependencies in other case self-tests. So it wouldn't be too radical a thing. It helps if the libraries are widely available in distributions. Otherwise, people will probably just not run the self-tests. If it's too much pain to enable it, but it's not a problem to rely on libraries per se. It's just a deployability issue.
Okay.
Yeah, but for our future proposal, it's kind of is an obstacle for us. So yeah, I will add more details. And so how we are currently testing our live patch modules using case self-tests. So they currently live on /lib live patch, and they are only compiled on kernel build. So, and you also need to add a specific K config to make those being built. So there's a question, how we test this, how we move those tests to machines without a specific cloned kernel source. And also about distro kernels, how do you use these tests on distro kernels that don't enable that option, right? And so that's the current way that we test these self-test tests, right? Sorry, the name is hard. So first we need to build the kernel using the config live patch and config test live patch, and install the modules, install the kernel, reboot, and then we go to the same machine and run make case of test targets equals live patch. So that doesn't scale. So if you want to test the same live patch self-test on different kernels, so yeah, we need to have the kernel source there to make that happen. And so what we have now, we also have this QA test KOP that lives in GitHub. These are out of 3 tests. These tests, they are compiled on the fly before the tests are running, and this is what our QA teams on SUSE are using before releasing a new version. And we have this idea about moving these tests to case self-tests, and that's how we came to that Gentar target. And yeah, that kind of is an obstacle since it compiles the modules, but then if you test on a different kernel, the ver magic doesn't match, and we can load the modules. Yeah, so one of the weak points of case self-test. Yeah, so how to get these tests to be run on different systems? I'm not sure if you guys have any ideas besides moving the kernel source to those machines. So yeah, if you have, please. Yeah, and also, as I said, currently there is a restriction in case of tests that they don't include kernel modules. And so if we include them, there are a couple of rules to build code inside case of tests, but there are no rules to build modules. We did that. But when, when the Gentar is run, those modules, they are packed together with the user space tools and tests. But then we can load those modules on different machines, right? Not different machines, but with different versions and different kernels. So yeah, so the Gentar, at least for us, is not that useful, or its purpose was not clear when we checked. So our proposal to the problem, I sent a patch set. It's already on V3. The first 2 versions had issues with kbuild and stuff, so I had to go through that. Kbuild is huge, and just to understand those cryptic rules is kind of difficult for one that is trying to implement something new. But yeah, I believe all those issues, they are addressed. Move our live patch tests to case self-tests, right? Where we currently have some bash scripts to test those modules. And with this move, we also remove that config test live patch config as well from the kernel. It was already being used in some different dev config on different architectures about S390 and PPC, if I remember correctly. So it's one less config to the kernel, which is always good. And yeah, so what we currently do is, before running the tests, I created a new target inside the case of tests, just to specify a directory containing modules, right? And yeah, just jump there, compile them, and then run the tests, and it works. So currently our test used modprobe just to load the modules because they were meant to be installed. But yeah, I had to change to insmod just to make sure it points to the right place. And now we need kernel headers to compile that, but yeah, I don't think that's a problem. And yeah, our proposal is just to port all other tests for QA test KOP GitHub repository. There are up to 15 tests there, if I remember correctly. And in this V3 version that I sent, I implemented the first of them, which live patches the get bid system call. And we have, if I remember correctly, some user space code on loop, just execute and get bid, and we make sure that they transition to the patched state. So just to make sure that we have this case covered about user space programs hammering hard on syscalls. And yeah, that works. So our idea is to port other tests that might be interesting to have on upstream. And yeah, sure.
Just a question. So what are these other tests? Could you?
Yeah, one of them is just as if you have K-probes enabled, and we just try to attach live patch functions. And yeah, and others. There are other tests that creates 10 modules and tries to apply them successfully, really fast, trying to get them right. And yeah, there's a couple of them I can't remember.
If I remember correctly, so we implemented a couple of those corner cases. So the interaction between live patch and K-red probes, K-probes.
Yes.
If we could patch a function which is on stack, I think so.
Yeah, there's a couple ones. So the one class is workloads, like Marcus said, hammering on syscalls and patching stuff, while patching stuff and making sure the transition proceeds nonetheless. And then there's other class of testing for the interaction between KLP and ftrace versus, for example, K-probes, and graph-based tracing had been. I think some are for actual issues we had in the past, so just like regression tests. So.
And if I can remember correctly, those tests catched a problem recently on PPC. I remember seeing something on the mailing list, some changes that were done. I'm not remember exactly what it was.
That was reported by Joe. LPC, yeah.
Yeah. But yeah, so they are really useful. So that's why we would like to upstream them. And by making the case of tests more flexible, maybe it encourages other people to also upstream their own live patch case of tests, and maybe other subsystems that people would like just to have the same purpose than us, that compile module on the target system before running the test. That doesn't seem a problem in my point of view.
I think, this identifies what's always been a bit of a gap in the sort of in-kernel testing infrastructure, which is we've got K-self-test really designed for testing things totally from user space, as you point out. I'm obligated to shill K-unit for testing things entirely from within the kernel, where, you have the advantage that, everything's supposed to be built into the kernel, but the disadvantage that if you're playing around with loading and unloading modules, you do need user space stuff to access that. It's the hybrid model in between that causes problems. And yeah, K-self-tests infrastructure hasn't really been designed around the idea that you don't have the kernel source available and you're not building everything yourself on that machine.
Yeah, and when I started testing, sorry. No, I just want to say that when I saw that Gentar target, I thought, okay, so let's start it, right? Let's build it. But yeah, it only copied the compiled sources.
Yeah, I was going to say, so recently I've been writing some K-unit tests for stack trace, for reliable stack trace stuff, which I'll try and get out soon. But one of the reasons that I used K-unit rather than K-self-test for driving much of things, A, is that obviously you can get the infrastructure, but B, it is significantly easier to go and throw that on a test system because you just throw one binary there. So if there were a way to have like in-kernel module loading hooks for this sort of thing, that would make it significantly easier to test this on a wide variety of like embedded systems under virtual machines on things and so on, because you just have to throw one binary and you have absolutely everything in one place and it's all in sync. So I think that it might be worth looking into what we can do for that.
Yeah, just real quick, just to let you know, I just found Shua. She's participating in another talk right now. She said she'll show up later, so I don't know if it's possible to.
Yeah, I invited her twice at least.
Well, no, she's actually she's
Yeah.
she's participating in it.
Okay,
so
yeah.
she can't. But she said she'll show up right after, like before this session ends. But I don't know. They might interrupt someone else's talk.
No, yeah. Yeah, but yeah, we'll be more than happy just to align the expectations, or maybe to clarify the purpose of the Gentar. But
Yeah. And is someone taking good notes, by the way? There is a chat, or there's a note thing you're supposed to be taking notes for. But that way you got at least some.
Yeah. Notes are taken.
Yeah. So one issue with forcing the build of the modules on the target system is that that's significantly increasing the resources required on the target system for testing. You need to ship an entire tool chain there, and run the compiler, which is a big uplift from what K-Self-Test currently does.
Just to follow up with, I guess, Mark's point. I know with the existing case self-tests, we at Red Hat, we build the self-test modules as part of the ordinary kernel build, and we can package them, send those pre-built binaries right in its own RPM. And if I don't know if the intention is to always build before running the tests, but I just wanted to highlight that I think if you do that, do we run into an interesting scenario where the ABI of the test may not match what is in the host kernel? In other words, does it know that it has all the features that it expected, since it's sort of added tree?
Yeah, I was just going to echo that. So yeah, people building tests at the same time as the kernel build and packaging them separately has some other problems, but solves this.
Yeah, so just maybe one more. Yeah, you're in queue. I know where to. So just one small remark, because I don't know if it was said before. So one of the advantages of building modules on the fly is also that you can suddenly, it is really flexible. So you can have something like a template, which you can modify, run, generate different kernel modules, then compile them and use them immediately. And you cannot do that with the precompiled thing, of course. Yeah, just.
So one other issue with building the modules at test time rather than at kernel build time is that if you're enforcing module signing, you can't sign with the ephemeral key that the kernel uses. You have to have some other mechanism, or you can't load the modules you build at all.
True.
Yeah, I didn't even consider about module signing and stuff. So yeah, I'm just trying to make it work for us. But yeah, I haven't even thought about that.
Because then it really depends on the whole scenario. So if you want to test on some production, which doesn't make sense, but okay, just in a wild where there are not as many things available as they should be, like the whole tool chain, as Mark mentioned before, or if you have a test farm where you can, somewhere internally where you can be allowed to do different things. I'm not sure. Yeah.
But what's the downside of having the module like inside the kernel? Like apart from using more space, let's say when we ship the kernel, but in that case we could even separate it and provide that as a separate package, let's say, so that we don't have to decouple, the build time and test time build. What are the main disadvantages of having like the situation as it is right now?
It's the burden for a new package, maybe, and one more thing to think about when running stuff. But Yeah, I haven't considered that creating a new package, but yeah, there are other code inside lib too that maybe would be nice to move into case of tests since they are used for testing. Maybe not, but yeah, I haven't considered. But that's for the so that is one case for us. So I'm not sure if maybe other modules inside there would be also.
Yeah, there's still the burden of having a new package at the stand, but
Yes.
maybe like other subsystems can move, like I'm talking from a distro perspective, of course. Other subsystems can provide a similar test module or more test modules and move everything into this testing package. I don't know, something like that.
That's an option that we haven't considered.
There already are some of the well, there are already config options that are forced on by the self-test, and there are a few modules that are only really useful for self-test or for testing that are like Steve mentioned, the ftrace use of the sample stuff, for example. So that's already a thing, and a lot of systems doing k-self-test testing do build a custom kernel to run a lot of the k-self tests due to their dependencies. I don't think it would be a big disruption for them if the live patching self-tests were to add an additional module to build. They just pick that up automatically and everything would work modulo the issues with the that already exist with the k-self-test kernel.
Maybe I'll bring her up, ask her the question you want to ask her.
Yeah, please ask the question again,
Okay.
because I just ran in from the other one.
Okay. Yeah. No problem. So yeah, our idea to move the code from lib live patch to case of tests is that ability that we would like just to. Yeah, I think that explained
Yes.
that the previous version, right?
We discussed that. So we landed that we don't want to move that, I think.
Yes.
Yeah.
Yeah. So, but why? Yeah, that wasn't very clear to us. Why the move is not possible since there is already a module there.
So we talked about it, and I think that BPF is a little bit different beast because of the reason. So I didn't want to set a precedence to have leaving it in that's the modules. We are not moving that to. It's a module, isn't it? Is it live patch module?
Our tests.
Yeah, your test.
Yes, they are.
It's a
They are
module.
modules as BPF too, so the same stuff.
Oh, okay. So yeah, it's your reasons for moving them are, just summarize them for me. Yeah.
I think I also want to argue that with the fact that it is kind of a different beast. When you said BPF is a different beast, live kernel patching is a different beast because it's not really a subsystem per se.
Mhm.
It's a way of modifying the kernel, and like BPF, the same thing. It's a way of modifying the kernel. So I think it's very much close to what BPF is doing. So I don't think you would be setting a precedence if you were to allow live patch because the DRM would say, well, live patch is doing it. It's basically like, no, there's a reason why live patch. I think that's the issue is because the code that the module is not part of the kernel at all. Same thing like BPF is not. Is that basically a way to sum it up? Okay.
Yeah. You're right, and that's also what Mark said before, that it would make some things easier for you as well. I call it properly. Yeah.
What I was saying was slightly distinct. It was the more for stuff like this where we're testing in kernel infrastructure, for having that in the kernel, like using KUnit rather than being driven from user space is significantly easier. Whether or not this is, where this lives doesn't really matter to me. My thing was just, if I can more easily drop that on a target system or virtual machine or whatever, that's easier because we can't really in all situations, get a gigantic full file system with compiler, etc. in there.
You want to be able to move, not have the dependency of the build into the kernel, and then you want to be able to move it around.
Yeah. From my point of view, like this would create this self-test like more standalone like tool, like this LTP tests are basically universal, so you could test any kernel version with the latest LTP. And with the current self-tests are basically kind of connected with the kernel that are with the kernel that are in that sources, because basically the tests depend on the modules that are built with the kernel, with the same kernel sources. But if we move the module sources into the self-test, then we might build like the binaries and also the modules that are basically needed just by the self-test from the self-test sources. And it might be kind of make them standalone product or standalone tool that might just be maintained like together with kernel. And it might make it more universal. And for example, for our QA team, it might be kind of easier to make a package from it, or I don't know. Oh, and also from the point of creating the self-test, it might be more useful, because now I basically have to always rebuild the modules like together with the kernel, and then upgrade the test scripts for these modules. And it's basically, yeah. And I do it the way that I install that I create the RPM, then I install it, and so on. So it's
Okay, so
like
you really want to be able to just take the test module and be able to move it from system to system without depending on the kernel. That's one thing.
Yeah.
The second thing you're mentioning is you want to be able to put it in other test suites if you so choose. And and this is one single module, I'm assuming, correct?
no, we are talking about like the live patch self-tests are using, I don't know, 10 modules at the moment,
Yes,
but I'm sure
around
that
10
there will
modules,
be more.
8, 10 modules.
We won't have any security implications, I suppose, if we move this module around and somebody, are there any security implications that we have to worry about?
I don't think so, because like you need a root rights to load the modules.
live patch,
So
yes.
yeah.
Okay, let's try.
Okay. Yeah, and our future work maybe was to just enable maybe some flag to Gentar, maybe to copy sources, maybe to keep the current approach, and then move the sources so the person who are created the Gentar can choose to copy only the binaries or the source code to being built. But yeah, that's an idea. So that's all that I had today. Thank you.
Okay, we still have 2 minutes. So are there more questions or comments?
Oh, sorry. Yeah.
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 All right. So if I understand the idea correctly, we should be able to run newer self-tests against an older kernel. Is that right?
Yes.
Okay. And so you probably don't have 1.5 minutes to answer this, but would that imply then the self-test should be aware of what the host kernel is running and what it supports? And does the live patching subsystem make that easy to, ascertain?
Yeah, no.
I'm
not sure.
So that would be future work, saying maybe make it easy so that the tester can somehow figure out what do I do for
Yeah,
this
I think
version,
we
that
might
version.
do a similar thing to what ftrace does do. So just,
okay, copy what they do.
The features are present, so it just unresolved. And
So yeah, self-tests in general, we have been able to run them on older kernels. That's the model. The only exception is BPF, because of reasons of LLVM, and then the way they need a certain environment, they can't do that. when we do this, I would like to keep that, that we can just take newer self-tests and be able to run on stables for good reasons, because you're getting more coverage. But also, it helps us as we add features we are testing going back to the older kernels.
So just to reiterate the point I was trying to make earlier is that K-self-test and things like ftrace generally have tested user space interfaces to their ftrace functionality, right? They're not testing the internal kernel parts of this sort of thing, which is a big difference. And so that's one of the reasons it's easy to write tests that carry on, that can work on older kernels, because you don't have internal API changes that break things at some point in time.
Well, technically we do, because the modules that we're testing is like the direct trampolines.
Sure, but the actual users, so I appreciate that. I don't run the test modules. The vast bulk of those tests are just shell scripts poking the sysfs interface, right? So you can get the vast majority of the benefit of those tests by just testing.
Yes. Okay, I guess so what you're saying is basically live kernel patching testing is useless without the module.
Yeah, and it's testing potentially core internal APIs that may change over time. So you can not necessarily live patch related, but whatever the thing you're actually testing patch on. So actually, there's, I think, more of a risk of breakage there. It might be minimal, it might be okay, but you're probably going to have to version the module and do a bunch of things there. And what we're saying about with KUnit earlier is that because that's in the kernel, if you can keep that, if it's possible to write tests in there, they're naturally going to be versioned with the kernel in there, and you can drive them from user space.
Yeah, and also one thing is the stuff that I'm testing a lot of times with ftrace, stuff like that, not all of it is going to be compiled on production systems, where live patch is done on production systems all the time. So you really want to be able to say, hey, can I test this production system without having to recompile the kernel with a new module?
So yeah, you do have to, right. So you do have to keep that in mind, that when you are testing that your module, since you're separating your module from the kernel, so you do want to make sure, that was the advantage with the LPC. When you are in there, it's part of the kernel, and then you were able to, shell scripts drove the test in the test module. But now you're separating that. So you do have more things to worry about depending on the kernel release versus your test module. So your test module, then you have to worry about, which we do now, because we do have tests that if we're running newer tests on a older kernel, even the syscalls, you might not have all the features supported. So you have to make sure that your tests can make a determination that your feature is not available to test. So the same things that apply to K-self-test, since you're removing it from the library, it's no longer in the kernel. So what happens is you will have a lot less tie to the kernel. So that's something you have to be concerned about. And then I would generally recommend for people, kernel developers though, to test the test and the kernel together, because that's the reason we have K-self-test. Having said that, if you do want to separate it, you do have to worry about all of those things.
I just wanted to say regarding the KUnit test, we definitely leave like test modules, because the live patching needs to test if it works when the live patch module is loaded and unloaded and so on.
So I won't say much, but I think there are things we could investigate there.
Okay, thank you. Okay, so now our last speaker, Mark.
How do I don't know how to. It's hidden. Hello, I'm Mark Rutland. I do lots of low-level ARM 64 bits, and I've somehow got involved in live patching. Right, so a lot of people are asking about live patching, and it's been around for a while. People have been asking about it for a while, so where is it? Well, the fundamental thing everyone's realized is we need reliable stack trace. So of course, that's what everyone's trying to work on. Unfortunately, that's actually the last thing that we need to enable because it depends on a huge number of other things aligning such that we can actually implement reliable stack trace. So for the last few years, we've actually done a lot of preparatory work that might not immediately seem related to live patching, but it's preparatory work. So all the work that's happened with ftrace, so stuff that Torsten from SUSE did with -f patchable function entry, so stuff that we did since then with ftrace with regs, with ARGs, with call ops, so we can do the actual patching reliably, and so we can actually do the actual patching quickly. And that latter part does actually matter a lot. We've done a bunch of things like we figured out the way that exception table fix-ups across the kernel worked was completely unsafe for reliable stack trace on pretty much all architectures. So we had to come up with a new mechanism for doing X-table fix-ups out of line. So we implemented that on ARM64. x86 followed suit. A bunch of other architectures are using that now. That's things. And a bunch of various things like templated unified entry assembly, narrowing down the problem for the bits that we know we're going to have trouble dealing with, like annotations in assembly for how to unwind those. So there's a lot of stuff that we've actually done, even though we haven't enabled reliable stack trace yet. And there are still a few things that we need to do. The big one that everyone is aware of is we need to figure out how to unwind across exception boundaries. This is why people keep on trying to attack with optool and all that sort of thing to give us that information. There are some gaps in ftrace and krepro trampolines where we know that there is a small window where we can't actually recover the return address. That's possible to fix. No one's done that yet. I have a plan. Hopefully we can get that done soon. False positives and no return functions is an open thing. So big problem is when the unwinder is unwinding, if it gets to a no return function, that no return function has a return address because of the way the architecture works, it's just there is something there. We're never actually going to return to that, but the unwinder thinks we will. And without metadata to distinguish that, the unwinder thinks we're going to return to something. Because of the way compilers generate no return functions, typically they will generate a regular call, which will be a branch and link on ARM64, into the no return function. No return function just like trails off the end. Sorry, and the caller just trails off the end because it knows it's never going to be returned to, so who cares what's next? And there'll be another function next. And so the unwinder believes that we're about to return into the next function, no matter what that happens to be. And that is a problem for live patching because for the consistency model, when we go and check which functions are still active, we'll assume that next function is active when it's not. Josh.
Yes, so one way to deal with that is if you know it's a call frame as opposed to an exception frame, the unwinder can subtract 1 from the instruction pointer always.
Yeah.
So it's looking at the instruction, the call instruction.
Yeah, so that is one thing that has been proposed on ARM64, but we don't always know that without metadata. So I'm just saying it's an open problem that we need to come up with a solution for. And obviously we've got assembly functions and trampolines that are not regular calling convention compliant. And we need some way of dealing with those, whether that's metadata, somehow rewriting them to be compliant. We can't do that in all cases because exception entry, early head.s type thing just simply cannot do that. So we need to come up with some solution for that. For those of you not familiar with ARM64, I just want to explain why unwinding across exception boundaries is painful. Because people think this is a lot easier than it is, and even if we have metadata, it's still painful. So on x86, the return address gets popped onto the stack by a call instruction. You do your thing, and eventually ret pulls it off the stack. On ARM64 and other architectures that have a link register, our call instruction is actually a branch and link. It moves the next instruction pointer into the link register and then branches to your function, and your return actually consumes the link register and goes back. Obviously that doesn't nest, so the function that you've called has to go and save that link register onto the stack somewhere. Our calling convention puts it into a thing called a frame record, which is pointed to by the frame pointer. That's at an arbitrary location within your actual stack frame, but there's a linked list and we can go and consume that. At function call boundaries, it's well defined. Your link register is your return address. The frame pointer points to your parent's frame record. That contains its return address and a pointer to the next one, the next one, the next one. So unwinding at function call boundaries is actually really simple. At exception boundaries, we don't know which of the two to look at. If we look at the link register, and we assume that's if we look at the frame pointer and we assume that's the first thing we should wind from, if the interrupted function hasn't saved its return address yet, we've just lost a return address. We might go and patch something that isn't safe to patch yet for the consistency model. If we start from the link register is permitted to contain garbage between saving and restoring it. And so we might get a false positive and assume that something's there in that we're about to return to when we're not going to return to it. That is bad for the consistency model because we can just get stuck indefinitely, assuming that we're about to return to something that we're trying to patch, even though we're not, because we could be in a tight loop. One of the proposals for ARM64 was just don't unwind reliably across exception boundaries. But I think practically speaking, that is not workable. Everyone has looked at the proposed preemption changes recently, getting rid of voluntary preemption or making that happen lazily. We'll know that that's going to mean that most preemption is going to happen across an exception boundary. And so, if and when that happens, even if we sprinkle conned reshared calls everywhere just for live patching, it's going to be painful to maintain. It's just not going to be practical. We also need to unwind across exception boundaries because it makes it much faster. We don't have to go and wait for a task to make some progress, return from an exception in order to discover that it wasn't in the function we cared about. So it makes it much simpler and much faster to iterate over all processes. And also we want to unwind across exception boundaries because real humans need that information anyway. Currently when we panic or dump backtrace, whatever, we are missing information and it's confusing people. People want that. People want it for perf unwinds and things like profile guarded optimization type thing. Yep. You got my print here.
So Mataban from our team posted some patches.
Yep.
Previously, like some months ago, that he's not able to attend today, but he's on the.
Yeah, I was going to talk about.
Yeah, so he says that I asked him. He said his patches do this correctly.
I will get to that.
Okay.
Yeah. So that's why we need to. That's why we need to unwind across exception boundaries. So I just wanted to get that across. The next thing is how we actually do that. There are two ways in which we can do that. One is to have some metadata to tell us when you go and look at the program counter, where is the actual return address. The other is to force the compiler into generating code in a particular way such that we can look at the PC and just know where the return address will be. Practically speaking, we need metadata. On x86, this is done with objtool. But using objtool, which was the approach that Madhavan Venkataraman proposed, is something we'd already knacked years ago. The reason for that is it relies on reverse engineering the control flow from the binary. This is not maintainable going forwards because we know that the compiler code generation is changing. It changes all the time. New instructions get added, new control flow sequences get added, new things change kernel side. And on the ARM64 side, our code generation has been changing more over the last few years than on the x86 side because we're a relatively newer architecture and so on. So we just don't want to get into that at all. So back in 2021 at this objtool ARM64 talk, we'd asked for what can we get from the compiler side. Unfortunately, at the time, we didn't really get much feedback from compiler, so we didn't really get that involved in talking, but India Begat's S-frame stuff actually looks like that might provide exactly what we need to do this. So that's, I think, what we're going to be looking at for ARM64 going forward, because that comes from the compiler, assuming the compiler doesn't have a compiler bug. Yep.
Yeah, this is perfect for C code. Well, how do you deal with manual written assembly?
We are perfectly happy to write the annotations for manually written assembly ourselves.
Oh.
Sorry, there's two things for that. There's two things. One is that we're trying to get rid of as much assembly as possible on ARM64. And two is that when I say we are perfectly happy to write that ourselves, if we have to write tooling to consume our own handwritten assembly, and we are in charge of that tooling, it's much easier to keep that in sync than it is to keep that tooling for consuming something that someone else has written, right? The key property that we want is that whoever writes the generates the instructions generates the unwind information associated with that. So if the compiler is generating the instructions, we want the compiler to generate it. If we're generating those instructions, we want ourselves to be in charge of generating that. And if we're delegating that to a tool that we've written, that's also fine, right? But we're keeping those concerns in the same place, and that's the critical property that we want. But good question, I appreciate.
Doesn't user space have the same problem unwinding through signals? Sorry. Doesn't user space have the same problem unwinding through signals?
Yes, user space does have the same problem unwinding through signals, and there is existing ways of handling that with Dwarf. I believe there'll be existing, and I believe S-Frame for user space will be able to solve the same. Right?
So what we have. Indy, you ready?
Yes, for S-Frame, I've been thinking about it. I think we do need the annotation that these specific frames are signal frames. We don't have that in V2, but it looks like we do need it. So next version.
Okay.
Yeah.
Sorry, and I have some things to ask for S-Frame later. Okay, so that's why we do need to unwind across exception boundaries, and why we're not going to reverse engineer the control flow, why we need something from the compiler.
Mark, is S-Frame not just a simplified version of Dwarf? I mean, just for the unwinding part. Is it not derived from Dwarf?
It is generated using the CFI sections, and to the question that is it a simplified version of Dwarf? Yes, it's very similar looking to ORC. Does that answer?
Yeah, one of the concerns from one of the reviewers was that Dwarf is unreliable, so that makes S-Frame also unreliable. So is there a proposal to make that reliable?
So just to counter that, I think one of the complaints from the ARM64 side is that ORC is unreliable. So I think no matter who's generating this, we need to fix the bugs in generating that.
Yes. Yeah, I think it just boils down to that. It is as unreliable as any other format generated by any other tooling. So
Linux is unreliable. No, sorry, but this is actually a key thing. I think one of the things we do need to do better between kernel community and compiler communities is actually getting this cross-pollination of, we've discovered this bug, let's go get it fixed.
Yes.
Rather than working around it and forever.
Okay, so with my Microsoft hat on, this is something we're really interested in. It's why Madhavan has been working on this. We also know that those patches, there are other companies actually shipping that in production because they need it, kind of large companies. So we would like to know if you can identify anything that we could possibly help with in this. We would definitely look into what we can do to help, and hopefully that's something we can talk about.
Sorry, absolutely. I think one of the key things is, so I know that when Madhavan posted his patches, he said that he had identified a bunch of potential code generation issues or dwarf generation issues. I can't recall which of those. Reporting those bugs to the compiler side would absolutely be a benefit. Testing patches would absolutely benefit. Saying on the list, we want this for this reason, and actually reviewing and testing patches would be one of the big things. You can ask a question? Oh, sorry.
Sorry.
And last question, can the Rust compiler generate S-frames?
Can we generate?
what is it doing currently? What do they do currently? Do they generate CFI annotations? Does the compiler do that? So the thing here is, if there are CFI annotations, I think, S-frame generation is at the moment in the assembler, and the interface to the rest of the tooling is CFI annotations. So if the compiler is able to generate CFI annotations for whatever, yeah, so that's it. That's all I wanted to say. If that interface exists and S-frame may be supported. It does, however, also depend on what are those stack frame layouts for those languages. So we need to be also cognizant of that. Yeah, that's all.
So I guess the question, the proxy question could be, does LLVM support S-frame generation, the LLVM assembler? So the Rust compiler will essentially use the LLVM backend to generate code. So once we have S-frame support for the LLVM assembler, we'll have S-frame support for Rust.
Yeah, I think, yeah, sorry. So, like, I think the thing that's important to focus on first of like who supports S-frame is this point about might be sufficient, right? To be crystal clear, to support unwinding out of exceptions, V2 S-frame is not sufficient. Come to the table with V3 and show us that this is the solution, then we will consider if we need to implement this. And the people who care about live patching can help fund the team to do that.
Sorry, just to be clear, the reason I put might be sufficient rather than is sufficient or is not is that I have only just started prototyping the last couple of days, that I know of a few edge cases where I think we can do the right thing. It's just a little bit more painful than we would have liked. I don't know of a specific issue that means it's broken or insufficient. Cool. Final slide. Right. So I mentioned before we did all that other rework as prerequisites, and one of the big things of all of that is that every prerequisite we've done so far is immediately useful. Right. So making it possible to unwind X tables correctly is immediately useful to humans. Making ftrace work better and more reliably, that's immediately useful to humans. Every single thing we've done so far has justified itself on its own merit and been a step towards this. So there's a few things that we want to do quickly in the near term. So passing additional information to the arch stack walk callbacks, restructuring that so we can pass more information down. We need that for implementing the reliable stack tracer so we can just get at more information rather than we having to implement an entirely parallel arch stack walk reliable that duplicates all the infrastructure. That's immediately useful for BPF and dump backtrace. So I'm going to try and get that out this merge window. Explicit identification of exception boundaries. That's some changes to the exception entry code so we can reliably say, this is an exception boundary. We know that the next thing is going to be PT regs, whatever. That's relatively simple to do. We want that for dump backtrace and so on. This will not allow us to distinguish whether the LR or the FP contains the actual return address, but it will at least allow us to print them both out and say, this may be the return address. So that we need to go and fix those gaps that I mentioned in the ftrace and krepro trampolines. That is relatively simple, but we need to make some changes to the core code. So it's just so that there's not a window where the return address has been taken off of the shadow stack and hasn't yet been placed into the real return address location. So we just need a callback for doing that in the right place. That's relatively easy to implement. And then the big next thing is prototype the S-frame kernel unwinder. I think on ARM64, the expectation is we're going to do this as a hybrid with our existing frame pointer unwinder, because our frame pointer unwinder works perfectly for synchronous unwinds, but when we get to exception boundaries, we need to go and figure out that difference. We could also use S-frame to validate the synchronous unwind, but there are a couple of edge cases with that just.
So for like dwarf, we typically strip the dwarf data out of the compressed kernel image that winds up on the target. So I guess this would, like the config would say like, if you need to support live patching, like you must ship the S-frame metadata in the.
Yes, so if you enabled config reliable stack trace, whatever it's called, you get that. My experiment from building that this morning was that for a def config kernel image, this is also about 3.5 megabytes of S-frame information. I don't know how that compares to other things like awk, but
like relative to dwarf, it's probably like 100th the size or something. Yeah. Right? Dwarf's huge.
Yeah, as part of that, we're going to have to identify any gaps we see. So the thing I mentioned earlier about distinguishing no return in cases, I'm not sure. I think S-frame might happen to give us enough information to distinguish that, but I haven't figured out if that is sufficient or not. There are other things that I believe you may know about, but.
For maybe a comment about no return, if you want to discuss that quickly. Yep. So typically the compiler will insert an implicit built-in unreachable after a call.
Yep. I would love for that to be generate a trap instruction.
Yeah, so there's, at least I know Clang has a flag to turn those into traps. Yep. And we discussed turning that on just as like a safety thing of like, what happened if a no return function actually did return?
No, so
something screwy is going on, you probably should just trap.
Yeah, so I would absolutely love that as a safety feature. My understanding, which could be mistaken, was that it was somewhat pessimistic and forced, and for functions where you, my understanding is it pessimized control flow in other ways, but I'm not immediately certain what I was thinking that was. So
I mean, I think because you could have other unreachables,
Yeah.
right? Like the programmer could explicitly use built-in unreachable. And so like you don't have fine-grained control in the compiler today to say only turn the no return calls into traps. It's going to turn all built-in unreachables into traps.
Yeah.
And so like I don't remember the code size difference off the top of my head, but it's like within 1% or something that I think is tolerable. And I think for security, like just turn it on. something that
I'd be happy to go and just try that if that's sufficient, and then come back with actual data.
Yeah.
And finally, like as was mentioned earlier, we do need a plan for handwritten assembly. There are going to be sequences which we cannot describe in SFrame because like we have the return address in a different register, and the way the SFrame works today is it's either location on the stack or unknown. So we know that we won't be able to describe that. There are cases we have where that's going to be like in the exception link register, which is a register that only makes sense in privileged code. So this isn't really a generic problem for a tool chain to solve. I think that's something where we're going to have to create our own annotations and our own like kernel specific things for those. But the big thing is we're trying to minimize the amount of cases that we have in the kernel for that. So I think that is going to be manageable. And that's it from me.
Okay, thank you, Mark. We still have time for questions and comments. Are there any?
So would you be using any unwind hints?
So I think we will be using, So yes, I think we'll be creating some hints. I'm not sure that those will be the same as the existing unwind hints that, in my opinion, are largely x86 specific. So I think we would, The concept would be the same. So at a high level, yes, we might refactor the existing unwind hints to reuse them, or we might make that a more architecture specific thing. But yes, I think we would have something of that sort.
For the no return aspect, I wanted to understand if this is something, so as I see it, it looks like it's something usable at this time for the unwinder. Is the no return, you guys were talking about the security aspect too, is this no return annotation something also useful for other use cases in the kernel?
So
if we just, so the intention here is to ask, should this be something annotated in the unwind formats, or should this go wider and get into maybe the object somehow?
Yes.
Is where I want to get at.
So that is a good question, and the thing is, I am not certain at the moment what level we need this. The reason that we care for the unwinder is two reasons. One is that for a human, if we're printing out a thing there that isn't actually return address, that's bad. It's just misleading. And two, for the actual live patch consistency model, it just means that like early kernel code, like when you start kthread, etc., that is all no return. It is entirely possible that every thread on the system has a completely bogus return address. And if that happens to be a function we want to live patch, we end up not being able to live patch it at all. So that's the reason we care for that. Whether that should be in the format, I don't know. But
well, I think my partially uninformed opinion or answer to that question, I think, is yes, because we kind of have this issue where, like, sometimes it's helpful to know, is a function no return, right? And anyone who calls it, they're all calling the no, like it's no return for all the callers, right? And so I think in Obstual, there's a table where we have to keep like a table of like no return functions. And like I don't think there's anything in Dwarf that says like this function is a no return function. And you might even not even be omitting debug info. So like, is Dwarf even the right place to put that? And so right now on x86, we have to kind of encode these out of line. And I just wish there was some way to answer the question universally of like, where are the no return functions in this binary? And you kind of have to like either look at the disassembly or keep an out of line table or something, right? Like
for the no return case, so the stack walker, does it really want to backtrace on the return address or on the actual caller address?
We cannot. So for reliable stack trace, we want the return address because we want to know where we're about to go to. We cannot reliably get the caller address because in some cases it does not exist.
So this is where I guess the reason why I might be asking is there's two use cases here where one is for debugging, you want to know who called that function. So you want the caller thing. But for live patching, you want to know where it's going to go back to because you don't care who called it. You care about where it's going to.
Yeah, and in my view, that's the difference between a return trace and a call trace. And what we have today is a return trace, right?
Oh, well, okay, yes, yes.
So you have to remember that the no returns are like, they theoretically could be lowered to a tail call, a jump. Instead, they're lowered as a call to make unwinding easier, which is like, it's actually harming us in this case.
Yes, so actually that's,
Like if it was a jump, like we wouldn't have this issue where the link register is pointing to the next instruction after the call, which like due to control flow layout, maybe like the beginning of the next function, right? So the current unwinder today sees like the call to the no return, and it looks at the link register is now pointing to the first instruction of the following function. So when unwinding, you're not even going back through the correct like caller. You're going through like the function after the
But
caller.
in this case, can you just offset and kind of say, well, in this
So
case,
just say -4
So-
or whatever.
-4, -1.
So I appreciate that. It's very easy to be lulled into a false sense of security that we
Yeah.
can always do that, whereas we cannot always do that because there are cases where -4 is not the
Right.
call
It-
address.
like the very first instruction in the function could be a call. And then like if you say -4, you're looking at.
Yeah. So the one thing
function
the one thing we've done for consistency today is it is a return trace because we can guarantee we can give you that aside from no return.
Yeah, I have a question. So how do you decide that the function is a no return?
We don't have that information today. I'm asking that.
You haven't
That's a
have
thing that we need.
information.
Yeah.
Do you need the information from the compiler?
Yeah.
Oh, okay. So what you mean by the false positive of no return? You mentioned a false positive no return in the very beginning of the slides, I remember. So that means the compiler passed some wrong information. It's a
Yes. So the issue was the one that was just described is, say you've got two functions, one after another, and function A and function B. Function A calls a no return function. Because the compiler knows that that is a no return function, that call to the no return function happens to be the last instruction of function A. So now when we go and unwind, and we unwind that no return function, we look at its return address, and it will be the first instruction of function B, even though we're never actually going to return to that. So that's the false positive, that it looks like that function is in the trace, even though it's never actually going to be returned to.
Okay.
So I'm almost curious of like, maybe we could have a compiler flag that could change, instead of lowering no return calls as calls, like tail call them. Like, I don't know what the trade-off would be. Like, does that break other stuff? But
So
like, the traditional answer of like, why does the compiler not lower no return calls as tail calls? And
It's so you can get a stack trace out. I would prefer the thing that we said earlier about if we have a trap instruction immediately following it.
A trap instruction would be good. Also, I'm like thinking, you have that the thing where you put padding in front of a function for the tracing.
Have it for
Is there a
afterwards.
way to after the function, or at least for like, so if
There
you
is-
just pick it?
So I don't believe there is currently a generic option that's shared by
So-
both GCC and Clang. But
So you need the compiler to mark all the non-return function. Or the compiler, if compiler analyze the routine, no return, I think it can do it, but it's do it conservatively. Only the real no return function it can mark it.
Yes.
Otherwise, it will have some
Yeah.
other impact.
Yeah, sorry, I agree. But I think where the compiler cannot tell a function is no return, its caller is going to have to assume it will return. And then we don't have the problem because the return PC will be within that caller.
So
Say when-
if compiler identifies no return function, it must be a no return function. But it's possible that one no return function cannot be. So so if it's a return function, but compiler mark it as a no return, then there's a compiler bug because that will introduce some wrong transformation. So compiler will not do that.
Sure.
Yeah.
Okay, no, time is up.
Okay.
It's lunchtime. Let's move the discussion there. Thank you. Thank you all. Thanks for the great discussion and enjoy the rest of the conference.
Ideally, there would be an instructor.
What?
But
compiler
I think
cannot.
the only case this happens is when you have functions that are marked as
But the user need to make sure that's a real return. Yeah, otherwise compiler will not responsible for that, right? Yeah, user is responsible.
Check, check, 1 and 2. It's this one here. That's true. And probably if I stood up there. Check, check. So I'm gonna try
Can I
cutting.
go listen to it on the feed? It sounds fine.
Oh, yeah. Weird.
I think it's because of
I'm gonna try cutting some of the lows and see if that helps with some of that. Because I'm guessing it'd be lower. Yeah.
Yeah. So.
So this is how most people talk. They talk like this. 1, 2, 3. 1, 2, 3. Check 1, 2, 3. 1, 2, 3. Check 1, 2. Microphone check 1, 2, 3. In ballroom B. Check 1, 2, 3. Check, check. So they're about this far away. Obviously, their voice isn't scratchy like mine. Sounds fine, right? Can you hear it? You can hear it. I can hear it. Okay. It's not terrible. I'm just.
Hello? Miguel? I cannot hear you guys. Hello?
There we go.
No.
The food in here was awesome. Yesterday it was like shit. For $38, it was awesome. They had super nice chicken, super nice beef. Yeah. Yesterday it was like crap. And we were here and we were, okay, let's just have something here. Right? The food today was awesome. Yesterday was shit. The buffet today was like wow. And shit.
Across the street, there's a fish place, like oyster bar. And it was really good because some fish and chips, bill, and
It's coming from there. It's catching the people there. Yeah.
Yeah, sure. Hello, Miguel.
Yeah. It's okay, we can hear you, man.
Yeah, the thing is, I'm hearing you very, very poorly at the moment.
Okay.
I think it might be if you go nearer to the microphone there on the pedestal, maybe.
The thing is, it's not still set up. The microphones are not working yet. They have to come and set it up.
Really, it seemed to me that the microphone worked before.
So this I
know, wait.
Yeah, that seems correct. Now I don't have sound anymore. Seems to work.
Hi, Beto.
Hello.
Testing my mic. Can you hear me?
Yes, I can hear you.
Right.
Miguel also gave a thumbs up, so he probably also can hear you.
Is the webcam also working? I can't hear what Miguel is saying. Right.